Okay, so good afternoon again. So pwede na natin i-start yung ating first key subject. So we have DC circuits. So basically, pagdating sa ating course, for our discipline, electrical engineering, so basically, no, pinaka-importante dyan ay yung ating mga circuits, no, from DC single phase up to polyphase. So napaka-importante niyan kasi yan din naman nagagamitin nating idea or principle in analyzing higher EE, no, yung mga machines at saka yung power system and power plant. So in dealing with electrical system, so basically, ang pag-uusapan natin, hindi tayo lalayo sa ating guiding principles. Basta sinabing circuits, ang pag-uusapan, it's all about Ohm's law. Hindi tayo lalayo dyan kay Ohm's law. So for Ohm's law, so Ohm's law always represent the relation between three important electrical quantity na palagi nating na-encounter. The voltage, the current, at saka yung ating resistance. So usually, kapag binalikan natin yung ating Ohm's law, so para hindi tayo maligaw dyan kay Ohm's law, usually, ang ginagawa na lang, so pwede natin kunin, we have circle, then this given circle, it is divided into three segments or three partition, ano? Oh, yep. So, pwede natin i-divide yan into three partition. So, sa taas, pwede natin ilagay yung ating E. And sa baba, you have the I, and you have R. So, alam natin, your E, that is acronym for our EMF. So, sinus EMF? EMF, that is the electromotive force. That is the external force applied to a given conductor or to a certain material that would cause the flow of electrons. So, basically, EMF, that is measured in terms of what? Voltage. And kapag dinefine natin si voltage, voltage, that is the equivalent work done per unit charge. No? So, voltage, that is also equivalent to unit of joules per coulomb. Kaya nga pag sinabi natin EMF, that is the required energy in order to push the given electron to travel from one atom into another. So that is the joule per coulomb. So therefore, once we applied the external force to a given conductor, that would tend to break out, to break the force of attraction between the electron and the proton. So definitely, meron tayong flow of electrons. So tawag natin, so I, that is based on the initials of your what? Intensity. So pag sinabi natin intensity, that is the intensity of the flow of electron per given time. So I, that would be our current, which is usually measured in terms of what? Ampere. At alam natin, ampere represent, hindi ko yung, ayun yung makuha. So ampere, that is the amount of electron that travel from one atom to another. So that is in terms of what? Coulomb per second. Intensity of the flow of electron from one atom into another. And alam natin, based on third law ni Newton. Anong third law ni Newton? So that is the law of interaction. For every action, there is always counter-opposite reaction. So therefore, the given material will offer its opposition or its reaction to the flow of electrons. At nga, yun na nga yung ating R that represent the resistance. Which is, according to George Simon Ohm, a physicist who first measured the opposition offered by this material to the flow of electrons, so it is measured in terms of ohms. So pagdating dyan sa ating EE subjects, so yan lang naman ang pag-uusapan natin. Ano? Hindi lalayo dyan yung ating mga formula or principle na kailangan balikan You have your E is equal to, kaya circuit yan. If you're looking for voltage, that is the product of current and resistance. Looking for the current, that is resistance over R. Looking for the resistance, that is E over I. So pagdating dyan sa E-subjects natin, so hindi tayo lalayo dito sa ating ohms law. So now for DC circuits, so ibig sabihin, yung ating EMF, that is only a direct current. So direct or battery lang yung ating supply. So balikan na lang natin yung iba pang topic na pwede natin ma-encounter in dealing with DC circuits as we try to solve this problem. So unahin natin si number 1. Compute the area in circular mill of a certain wire with a diameter of 0.1258. So basically, alam naman natin, for any given conductor, usually, pag kinuha natin yung cross-section of yun ng ating conductor, that is basically circular in cross-section. Ano? So assuming we have the given conductor, so kunin natin yung kanyang diameter. Let us consider in terms of B. So using metric system, alam natin area for circular cross-section, that is only 1. Pi over 4 D squared. So wherein in metric system, usually the area of our conductor, it is measured in square millimeter as specified dun sa ating PEC. Now you may also measure, pwede rin natin sukatin yung area ng ating conductor in terms of what? D squared. So pag D squared lang, the unit, it should be capital cm, or that is already in circular mill. So that is in circular mill, that is, if your diameter, it is measured in terms of what? Mils or mils. No? You may use area as D squared, wherein the unit is circular mill. So if the given diameter, that is in terms of mil. So ito, conversion. Recall lang that in order to express the diameter in mils, so the conversion that for every 1 inch of length or diameter, it is equivalent to 1,000 mils. Yun lang yung ating conversion. So, pwede natin ngayon kunin yung area in terms of circular mill. So, especially, yung mga conductor na ginagamit natin for transmission line, usually, their cross-sectional area, it is measured in terms of what? Circular mill. So, therefore, walang tayong problema if the diameter of this given conductor that is measured as 0.125 inch. So, hinahanap lang area o bonus yan. Ano? What would be the corresponding area of this conductor measured in what? Circular mill. So, pwede na natin diretsuhin. So, let us just convert. No? 0.125 inch. I-multiply na lang natin that there are 1,000 mils per inch. Then you just square. So, pwede na natin i-cancel out yung unit of inch. So, you have now the area measured in circular mill. So, yun na siya kapatid. Mode 1 ko na lang yung ating calculate. So, obviously, 0.125 times 1,000 is 125. Then, square na lang natin. So, we have now the final. And this is 15,625 capital cm read as what? Circular. Yan ang hinahanap ng ating problem. Diba? Napaka-basic lang. Anong letter yan? Papakita. So, although madali yan, basically, yung mga pinag-uusapan natin, mga board exam problem na yan. No? Lumabas na yan sa mga previous board exam. Actually, pagdating sa board exam, more on principles. Kaya kailangan alam natin yung basic principle per corresponding subject matter. Okay, so iwan ko si number 1, that is only computations of our corresponding area. Number 2, how many volts are there in 1 volt? Sino ba si volts? So kung babalikan lang natin yung ating Michael Faradays. Ano ba sinasabi ni Michael Faraday sa kanya? No? That is the law of electromagnetic induction. So, Michael Faraday's law of electromagnetic induction. So, ano sinasabi niya kay electromagnetic induction? That whenever there is a changes or cutting of flux within a coil, voltage is induced. No? Yung ating electromagnetic induction law. So, according to Michael Faraday, in its corresponding electromagnetic induction law, that whenever there's a changes or cutting of flux within a coil, voltage is induced. So, pag sinabi lang natin induced voltage, so basically, it only represents there is no physical or electrical connection between the corresponding coil and the magnetic kind of force. Kaya kung babalikan natin, according to Michael Faraday, electromagnetic induction has two types of induced voltage. Meron tayong statically induced voltage at saka dynamically induced voltage. Ano yung statically? Kapag binalikan natin, that is N dP over dt. Statically, which means the given conductor is at rest. Dynamically, general formula, that is our what? DLB multiplied kanina. Sin theta, dynamically, since you have a continuous rotation of our given conductor within the magnetic line of force. So therefore, kapag in-express natin yan in terms of our generator, the generated voltage in the given machines or E, pwede natin i-consider yan. That is JP plus N all over what? 68A. Where A, that is the number of conductor, P is the pole, N is the speed of rotation, A is parallel paths, and basically, yung ating flux per pole. So in SI, ano yung SI o yung ating metric system? Ano yung metric system? That is also your MKS system, meter kilo seconds. So in SI, the unit of our flux, it should be in terms of what? Weber. Now, you may also measure this given flux in terms of what? CGS system. So pag sinabi natin CGS, centimeter gram seconds, ano unit ng flux sa ating CGS? Alala ba? Ano unit of flux in CGS system? Anyone from the group? Alala? Ano unit ng ating flux doon sa ating CGS system? So tama ba? That the unit of flux in CGS system, that is what? Maxwell, di ba? So therefore, if the given flux, it is measured in SI, so our generated or induced voltage according to Michael Faraday, it is measured dun sa unit of what? Volts or voltage. Now, if the given flux that is measured in CGS, nakamesh sa CGS, ang unit daw ng ating volt is what? A volt. To represent that is what? Absolute volt. So absolute volt, that is just a unit of our EMF in CGS system. So therefore, if we want to get the value of a volts in 1 volts, so alam natin kapatid, the only difference is the unit of flux. So you just recall that in metric system, 1 Weber is how many Maxwell? Ilan yan? 1 Weber, how many Maxwell? Sa ano value? So pwede nyo i-comment pag alam, no? Sa ano value yan? That is 10 raised to 8 Maxwell. So that is also the conversion between voltage and amp-volts. So ibig sabihin, amp-volts, that is the unit of our induced voltage in CGS system, which conclude that for every 1 volt, it is always equal to 10 raised to 8 amp-volts. Yun ang hinahanap natin. Okay, kung alam natin kung ano yung pinagkaiba ng metric sa CGS, so hindi tayo maliligaw kung sino yung amp-volts na binabanggit ng ating problem. So therefore, at this case, anong sagot natin? So that is cut-start. Amp-volts, acronym for absolute volt, that is the CGS unit for our induced voltage, wherein the corresponding flux, it is measured in Weber. Kaya nga, di ba? Pag-convert natin into volts, convert mo lang yung flux into Weber, you have only a multiplier of what? 10 raised to negative 8. Alright? So, any question regarding problem number 2? Okay tayo kay number 2? So, iwan ko si problem number 2. So, let us try next problem. Number 3. So, for problem number 3, a certain wire has a resistance X. The resistance of another wire identical with the first, except for having twice greater than its diameter. So before natin i-solve si problem number 3, although madali na solve yan, so let's just recall yung ating law of resistance. Okay? So ano ba yung ating law of resistance? So law of resistance focuses on the different factor that affects the resistance of any given material, which is based on George Simon's ohm. So anong nakita ni George during the analysis of the resistance of a given material? So according to George Simon Ohm, he found out that the resistance of any given material, it is proportional to its length, L. So ano ibig sabihin? As the length increases, resistance increases. Kaya nga anong ginawa niya? Kinompare niya yung resistance ng Pilipino sa resistance ng US citizen. Kinompare niya yung resistance ng Pilipino at saka Amerikano. Sino daw ang mas mataas sa resistance? Ang Pilipino ba o ang Amerikano? So sabi niya, Amerikano. Bakit sir? Kasi mas mahaba. Mas mahaba. So mataas ang resistance. So that is the first factor. Resistance proportional to its length. Now another, he also found out that the resistance of a conductor inversely proportional to the area. So pag sinabi natin inversely, as the area increases, resistance decreases. But once the area decreases, resistance increases. Kaya nga kinumpare niya, alin ba mas mataas ang resistance? Yung dalana o dalaga? Di ba? Alin yung mas mataas ang resistance? Yung dalana o dalaga? Di ba? Pagka dalaga, maliit pa ang cross-sectional niyan. Masikip pa. Pero ang dalana, di ba, dala na, marami na pumasok na malaking mahabang length yan. So therefore, ano nangyari? Malaki na cross-section. Mahina na ang resistance. So yun siya, no? Inversely proportional to the cross-sectional area. And at the same time, he also found out that another factor that affects the resistance of the material is the change in temperature. Yun nga lang, the effect of change in temperature depending on the given material. Kasi alam natin, marami tayong klase ng material, but different materials can be classified or can be grouped into 3 based on electrical property. Sino yun? No? Materials can be considered as conductor, insulator, at saka semiconductor. Diba? So, iba effect ng change in temperature sa conductor compare sa insulator and also in the semiconductor. So basically, pag-usapan muna natin itong two main factor that affects the resistance of the given material, that is the length and the corresponding diameter. Kaya pag pinagsama natin ito, kapatid, you have the resistance, palitan natin ng equal sign, yung proportional design, maglagay tayo na constant. So our resistivity. Now that is rho L over A. So doon natin nakuha yung specific formula in solving for the resistance of this given material. Now, saan ko gusto tayo mag-focus? So let us try to consider here dito sa ating resistance. So resistance is directly proportional to its length. So therefore, using this given relation, pwede natin i-compare na yun. Now, we may compare two materials that is made, or two conductor that is made of same material but differs only in terms of length. So let's see, meron tayong dalawang conductor. no? Ito yung ating first conductor. Then we have another conductor wherein that is made of same material, but at this case, it differs only in terms of length. Ito magkatapat. Tatapin ko na lang. Okay, so let's say you want to compare the resistance of these two given conductor that is made up of same material. So let us consider this would be our resistance of the first conductor, wherein its initial length or its length is L1, and this would be the resistance of the second conductor, wherein its length is L2. So since alam natin, directly proportional, so using the relation given by George Simon Ohm, so pwede natin i-compare yung resistance nitong dalawang conductor na yan that is made of same material but differs only in the corresponding length. So pwede natin gamitin using ratio and proportion that the ratio of final or R2 over R1, it should be also the same as what L2 over L1. So that is based on the given first factor. Now another, let's say, we compare naman two conductor, pero at this case, it differs only in terms of cross-section of the earth. So let's say naman, no, in terms of the cross-sectional area, so mas malaki ito. Let us consider this is your initial conductor. Its given diameter, sabihin natin is D1. So another conductor that is made of same material, ito yung kanyang diameter. So alam naman natin that resistance inversely proportional to the area. So therefore, pag kinuha natin yung relation ng ating resistance in terms of area, so that is R2 over R1, pag inversely, it should be A1 over 1. A2. Eh, alam naman natin that the corresponding area, it is always proportional kanino? Square of the diameter. Kasi alam natin area is pi over 4d squared or simply d squared. So pwede rin natin sabihin that the resistance, it is inversely proportional to the square of its diameter. Kaya pwede natin din kunin yan as what? D1 over what? D2 quantity squared. Tama ba? So this given ratio and proportion, pwede natin gamitin itong mga equation na yan for comparing two materials or two conductor made of same materials differs only in terms of what? Physical dimension. Either difference in terms of length or ang difference nila in terms of the diameter. So pwede natin gamitin yan getting or comparing two conductor made of same material differs only in physical dimension. So therefore, for problem number 3, we have two given material. The first material has the resistance X. Now, the only difference between the first and second conductor that is, based on problem, the given diameter, no, except for having twice greater than its diameter. So ano ibig sabihin, ano? So let us consider for problem number 3. Ito na lang ang gamitin ko final, no? Walang problema doon. Ito gamitin ko 1. Let's say the resistance of our first conductor R1, that is X. Its initial diameter D1, let us consider that is D. Now, we are looking what would be the possible value of the resistance of the second conductor, wherein it only differs on its given diameter. Ano yung final diameter niya? Maliwanag sa problem. With the first, except for having twice greater than its diameter. So, ano magiging value ng ating d sub 2? So, d sub 2 here, pag nilagay natin dito, maliwanag, no? Having twice greater than its diameter. Sinong diameter dito? That is the diameter of the first conductor, which is d1. Greater than, so plus. Pag sinabing twice, times 2 pa. So therefore, this is twice of what? D1. So lumalabas, R2 or D2, it should be what? 3 times of the initial diameter. Nakuha ba? So that would be the relation between the initial and final diameter. So the resistance of another wire identical with the first, except for having twice greater than its diameter. So diameter ng ating first conductor, you get the equation from right to left. Ito mo siya baybayin. So diameter ng first, D1, greater than, plus, twice pa, times 2. Kaya D2, it is just 3 times the initial. So therefore, using this relation, makukuha natin ano na yung final resistance. So using the idea that resistance is inversely proportional to the square of the diameter. So, gagawin din na lang natin yan, yung using ratio and proportion, wherein nakuha na natin kanina that R2 over R1, it should be equal kanina. D1 over D2, quantity is squared. So, in that case, we can see now that R2 equal. Cross-multiply si R1, which is only X. Retain natin si D1 as D. D2 is 3D1, or that is 3 times D. So, quantity is squared. Cancel yan. So, kita na natin that the final resistance, it is just 1 all over 9 of the initial resistance, X. So, yun ang hinahanap natin. So, the resistance of the second conductor having greater diameter, so that is 1 over 9 initial resistance. So, that is only dog style. Ba? Any question regarding problem number 3? Comparing resistance of two conductors made of same material differs only in the physical dimension. Kuha ba? Any question regarding problem number? Sir, bakit nga D plus D2 yun, sir? Okay. So, in getting the equivalent equations, no? Pag kinuha mo yung equivalent equations from worded problem, getting the mathematical equation. So, minsan pag hindi tayo sanay kung paano kunin yan, at least alam natin yung mga simple words. Di ba? Pag greater than, more than, represent plus yun. Less than, okay? Less than, so that is usually minus. So ngayon, in getting the corresponding equation, minsan, pagka nagpa-practice ka pa lang, pwede mo silang baybayin. So, di ba pag binabasa natin left, right, pero pag kukunin mo yung mathematical equation niya, mas madali mo siyang makukuha, baybayin mo siya, kunin mo yung sentence, right to left. Mag-right to left ka. So, paano right to left? So, at this case, diameter. Sinong diameter ito? Kino-compare natin yung diameter ng second sa first. So, diameter of the first, that is D1. Greater than, that is plus. Eh, pag sinabing twice, times 2 yun, di ba? Times 2, no? Pagka thrice, times 3. So, twice yan. So, times 2 pa nung ating initial diameter. Kaya lumabas, D2, it is just 3D1. Iba naman kasi pagka sinabing except having twice its diameter. Pag sinabing twice its diameter, so wala yung greater than, doon lang sila lalabas na 2D. Pero nandoon yung term na greater than, so it should be 3 times D1. It is also the same as having thrice its diameter. So instead na binanggit na thrice, ginawa niyang konti pang dito, so twice greater than. Kasi yung unang lumabas na tanong, ang binigay lang doon is twice its diameter. Yung original niyan. Kaya nilagay niya itong greater than. Kaya lumabas, it should be 3D1. Nakuha ba? So, pagdating doon, medyo apply natin yung idea of getting mathematical equations out of the worded problem. Siyempre, papasok doon yung ating mathematics. Okay? Kuha ba? So, usually, kahit ako dati, so medyo, lalo na pagka naghalo-halo na yung as, was, di ba? Doon sa age problem sa mathematics, pagka as, was na yun ang medyo complicated. Dapat makuha may equivalent equation. So, usually, ang ginagawa doon, baybayin mo yung sentence right to left. So, makukuha mo yung equivalent equation. Okay? Any more questions regarding that? So, I want to see number 3. Number 4. Okay. A given wire has a resistance of 45 ohms. If its length is 160 meters. How much length must be cut off from the wire in order to reduce its resistance to 35 ohms? So, ano ibig sabihin? Ano? So, let's see, graduating tayo. Alam naman natin, pag graduating, napakaraming projects na kailangan isubmit. Unfortunately, so alam natin, isa sa ating behavior, no? Pagka malayo pa, petics muna. Pero pagka mga 2 weeks na lang submission, doon na natin raratratin. So unfortunately, let us consider, meron na tayong kailangan submission tomorrow. So tatapusin na natin yung project, ginabi na tayo. So in a given project, kailangan natin ng conductor. Kailangan natin ng certain resistance. So let's say, fortunately, meron tayong available material. Let's say the available conductor, ito yung kanyang initial length. So kinuha natin its original length. Let us consider L sub 1, that is 160 meter swimming. Then we have found out that its resistance is equivalent to what? 45 ohm. Unfortunately, the required resistance para doon sa ating project na kailangan ng isubmit tomorrow, 35. Ang available natin is 45. Madaling araw, hindi ka na makakabili. No, wala, sarado na. Assume, sarado na lahat ng pwedeng bilihan ng mga electronic devices or electronic component. So therefore, kung hindi natin mapoprovide yung ating material, so sayang naman. So therefore, nakaisip ka ng paraan. Since we all know that according to Jones, directly proportional to its length, so therefore, in order to reduce the resistance available to our required value, so one way to reduce it is to reduce its corresponding length. So anong ginawa mo? Kumuha ka ng gunting, kumuha ng pamputol, pinutol natin yan. Sabihin na lang natin, eto na ngayon yung panibagong conductor natin. So hindi natin alam what would be its final length, but kailangan the resistance of this conductor should be now equal to the required resistance to sa ating project, which is what? 35 ohms. So ngayon, ito hinanap ng problem. What would be the equivalent length to be cut off from the original conductor to provide the required resistance? So let us consider, ito na lang, gaano kahaba ito na kailangan natin putulin? So let us consider that is what? Delta L. So hinahanap, how much length of our available material should be cut off. So in terms of length, pwede natin sabihin that is L1 minus kanino lang, L2. No? At what condition that the resistance would be reduced kanino? 35 ohms. So gaano kalaki kailangan natin putulin? So therefore, alam na natin si L1, kakailanganin na lang natin si L2. So alam natin kapatid, according to George, resistance is directly proportional to its length. So again, using ratio and proportion. So comparing the final resistance over the initial resistance of our conductor, it should be equal kanino? L2 over L1. So using this equation, makukuha natin that L2 should be only equal kanino? L1 quantity R2 over kanino? R1. So therefore, para isang compute tayo, kunin ko na lang ito, no? Tapos, kapatid gawin mo, ipasok dito, dahan-dahan. Yan. Ipasok mo na dahan-dahan para swap eh. Diba? Kailangan pag nagpapasok ka, yung medyo dahan-dahan lang, di ba? Para hindi masaktan. Parang swabe-swabe. Para in case, no? Makaulit ka. Pagka binigla mo yan at nasaktan, hindi ka makakaulit. Kailangan yung swabe lang, di ba? Para may chance ka pa makaulit. So, ganun din sa board exam. Sabihin, pagka ikaw ay nag-shade na, siguraduhin mo, dahan-dahanin. Kasi pagka na-shadean mo na yun, nagkamali ka pala ng shade, hindi na pwedeng umulit. Hindi pwede ang erasure. Kaya pagka nagpapasok ka, dahan-dahan, swabe-swabe. Tapos ano ba sabi ni Albert Einstein do sa theory of relativity? Familiar kayo sa theory of relativity ni Albert Einstein? Ano sinasabi ni Albert Einstein sa length? Na kapag ka daw yung movement ng isang bagay ay pabilis ng pabilis, habang bumibilis yung kanyang galaw, ano nangyari sa kanyang equivalent length? Lumiliit, di ba? Ito yung parang nilalaro natin, laro mo na yung ballpen, back and forth. So habang pabilis ng pabilis, anong tingin mo sa ballpen? Lumiliit, di ba? So yun din ang sinabi ni Albert. Kaya pag nagpasok ka, dahan-dahan, para in case hindi siya ganun kalakihan, kahabaan, buong buo. Pero pag binilisan mo yan, maliit na nga, binilisan mo pa, eh lalong liliit yan. Yan ang sinasabi. Okay? So therefore, after mong ipasok, ito na siya. Lalabas na. Yan. Pagka naipasok mo niya swabe-swabe, lalabas na. So therefore, the amount to be cut off from the original length, factored out ko na lang si L1, so you have 1 minus 1. R2 over R1. So, kuha na natin. Original length, alam natin, is 160 quantity. 1 minus, ano yung required resistance do sa ating project? 35. Available is what? 45. So, in that case, we have to cut the available material by how many? 160 times the quantity 1 minus 35 over 45 equal 160, 35, 320, or that is 35.5. Anong unit? Meter. That should be the answer. So you have to cut the given material by 35.55 or sabihin na natin rounded of 6. So you have to cut by 35.6 to reduce the resistance of the material to 35 ohms. So yun ay nahanap ng ating problem. Ang letter 35.6 ay yung cut style. Ako ha? Any question regarding problem number 4? Direct substitution lang. Okay? So, iwan ko si number 4. Number 3. Number 3. Number 5. So, for number 5, a meter of wire having a diameter of 7.5 millimeter and its resistance is 0.31. Drawn down. Ano yung drawn down, kapatid? For drone process. At drone process, kumbaga, this will be the process done in order to provide different sizes of wire. So kung na-try natin, kung nagkaroon tayo ng opportunity na makabisita sa mga planta ng mga wire, no? So makikita natin kung paano ginagawa dyan sa drone process to provide different sizes of wire. Kasi alam natin yung ating mga metal, isa sa property niyan is being elastic. So at a certain temperature, so nag-elongate yan. So pag pinainitan mo yung metal na yan, so medyo nag-elongate. So ngayon, para mas lumaki yung elongation, babanatin natin yan. So pag binanat natin, yun tinatawag natin drone process. So kumbaga yung rubber, so kapag hindi mo binanat, medyo malaki yung cross-section. Pero pag binanat mo, ano nangyari? Humahaba pero lumiliit yung cross-section. So let us consider, initially, ito yung ating conductor. So maiksi pero medyo makapal. So after drone process, Okay? So, draw that scale. So, let us consider, ito yung ating original conductor. Sabihin na lang natin, its length is L1 and its diameter is D1. So, its resistance is R1. So, after it was drawn down, so obviously, natin, mas mahaba na yung kanyang length, but its diameter decreases, and let us consider this would be its resistance. So what happened to the resistance of a given conductor after it was drawn down? Ano ba magiging epekto no, sa kanyang resistance? So tulad ng binanggit natin, at drawn process, binabanat lang natin yan. So the idea at drawn process, it is always considered that the amount of material, it is held constant. So ibig sabihin, kung gaano karami ito in terms of mass, no? Kung gaano karami ito, ganun din karami ito. Walang magbabago sa kanyang mass. Or simply, it is always considered that the volume of the material, it is held to be constant. Ngayon, kung kukunin natin ang volume, di ba, yung ating conductor, pag kumuha tayo ng certain portion, para siyang cylinder. Tama ba? Kasi circular ang cross-section. So lumalabas, solving for its volume, that is the product of area times L. Ako ha? Kaya kung gusto natin kunin what happened to the resistance after it was drawn down, so babalikan natin yung formula ng ating resistance given by George Simon O. Rho L over what? A. Okay? So let us consider, multiply ko to sa area over area. So walang problema, di ba? Area over area, that is 1. So therefore, pag binultiply natin, you have rho, length, times area represent the volume of this given material. So you have B. I-divide natin kanina. Area squared. Now, alam natin, if this conductor and this conductor are just the same, binanat lang natin. So they are made of same material. So resistivity is constant for this given material. At yung volume is also constant. So ano pwede natin sabihin? So at this case, under drawn process, it was found out that the resistance, it is now inversely proportional kanino? Square of the area. Tama ba? And consequently, since area is proportional to the square of diameter, so pwede rin natin sabihin, resistance under drawn process inversely proportional to diameter raised to 4. Nakuha ba? Ito yun, 8 times 8, 8 squared. Since resistivity is constant, volume is also constant under drawn process, so pwede nating sabihin that the resistance of the material under drawn process, it is now inversely proportional to the square of its area. Okay? So pwede rin, what happened to the corresponding length? So let's say, ito pa rin yung ating general formula for the resistance. So tingnan naman natin, what would be the corresponding effect if length naman ang kinonsidered. So same idea, let us just multiply the whole equation by length over length naman. So walang problema yun, no? Anong matitira kapatid? You have rho L squared over what? Volume. So let alam natin, resistivity and volume for this material, it is held constant. So in that case, we may consider that resistance, it is directly proportional kanina. Square of gap. We know the effect to the resistance of the material once this material undergo drawn process. So, ibig sabihin, this given relation, it is only applicable comparing to the final and initial resistance of a given conductor that undergo drawn process. So, pag wala yung drawn process na yan, babalik tayo dun sa original relations na ginamit natin, comparing two different or two material or two conductors made of same material differs only in physical dimension. Dito, isang material lang ang pinag-uusapan natin, nagkaroon na ng changes sa kanyang dimension because of this given process. Okay? So therefore, if we try to apply it to problem number 5, sabihin natin that initially, the diameter of this given conductor, 7.5 millimeter. We have found out its resistance is what? 0.31 ohms. After it was drawn down, umaba yan, pero we have found out its diameter decreases to what? 2.5 millimeter. Ano hinahanap? What would be the value of R2? Okay? So since diameter ang given, so using the idea at drone process, resistance is inversely proportional to the fourth power of your diameter. So again, using ratio and proportion, pwede natin ngayon i-compare final resistance after the process over its initial resistance. It should be equal to D1 over D2 closed quantity raised to 4. Okay? So therefore, no more problem. Kuha na natin yung ating final resistance. So its final resistance R2 should be R1, which is 0.31. D1, initial diameter, is 7.5 over final diameter of 2.5 raised to 4. So this should be the final resistance. Okay? Ano lumabas ka ba dito? 0.31 multiply 7.5 over 2.5 raised to 4. Tsaka natin equal. So this should be the answer. Ano lumabas ka ba dito? 25.11 ohms. That should be our final answer. Yun lang. Yun ang masaklap. 25.11 is not available sa choices. So, ganyan yung mga possible scenario na lumabas sa board exam. Pag simple yung question, minsan may mga errors. No, ganun talaga sa board exam. Hindi may iwasan. Wala pang lumabas na board exam, wala pang nag-take ng board exam, o wala pang board exam na walang error na lumabas. Mga 5 problems, at most 5 problems, minsan may mga error yan. So in that case, pagdating sa board exam, hindi pwedeng ilagay doon na none of the above. Hindi pwede yun. Kung ano yung nasa choices, yun dapat ang lalabas na answer. So in this case, hahanapin natin yung correction. Okay? Ano yung correction? So eto siya. Hindi ko masabing correction. No? Kasi ang gagamitin ko, maling solution para lalabas yung answer sa choices. Okay? Kumbaga, i-modify ko yung solution ko para habulin yung nasa choices. Paano yun? So instead of using the relation of resistance in terms of diameter under drawn process, ano yung nangyari? Yung correction dyan, the correction, the given problem, it was solved using resistance is inversely proportional to the square of diameter. Yun lang ginamit. Pero take note, this given relation, it is only applied comparing two conductor made of same material. Comparing to conductor. Ito kapatid, nagko-compare lang tayo sa final at saka initial. Ibig sabihin, isang conductor yan. Binanat lang natin. Kaya dapat, ito yun. Kaya lang, ang ginamit dyan, squared lang. Hindi na raised to 4. Bakit naging raised to 4? Kasi alam natin, this area, it is proportional to square of diameter. Kaya kapag sinubstitute mo dito, square times 2 by law of exponent raised to 4 dapat. Kaya lang dito sa problem, ang nagamit, this squared lang. Kaya kung ito yung gagamitin natin, doon lalabas yung answer na available. Okay, nakuha ba? So therefore, using this relation, R2 now, ano si R1, 0.31 multiplied 7.5 over 2.5 quantity is squared. So instead na naka-raise to 4, square lang ginamit. Tsaka may equal. Ayun na sagot. Ano lumabas? 2.79. That should be the answer available on the choices. Meron ba? Ayun, lumabas. So, ibig sabihin, this should be the correct answer. Baligtad. So, may mga ganyan sa board exam. Minsan, kailangan mo i-modify ang solutions para lumabas yung answer available on the choices. Hindi kasi pwede yung none of the above. No? Kahit 100% ka sa solution mo, pag wala sa choices, so kailangan mo hagilapin ano yung correction dyan sa problem. So, ang naging correction dyan, kapatid, parang hirap niya sabihin, no? Ang correction, gumamit ka ng maling solution. Diba? Yun ang correction dito. Gumamit ka ng maling relation. Kaya ang hirap niya sabihin na correction. Sir, paano naging correction? Maling solution ang ginamit natin. Yun siya, no? So, yun talaga scenario pagdating sa board exam. Kailangan natin mapalabas kung ano yung available choices or anong available answer sa mga choices. Hindi pwedeng ipilit yung atin. Wala sa choices na none of the above or walang letter E. 4 lang. A, B, C, D. Walang none of the above. Pwede pa all of the above pero none of the above letter E. So malabo. Pwede rin naman na none of the above in case pang letter D siya. Pero kung may mga value lahat, hindi pwede ilagay no answer. Sigurado mag-error yung exam mo doon. Okay, nakuha ba? So that should be the correction for this given problem. Gumamit tayo ng maling relation with respect to the resistance and the diameter of the conductor. Okay? So any question regarding problem number 5? So iwan ko si number 5, ano? Let us try number 6. So number 6, again, we have a copper wire of unknown length has a resistance of 0.8. By successive passes through drawing dies, the length of the wire increased by 2.5 its original value. So, yung key concept na kailangan natin tignan dito, ano ba ibig sabihin ng increased by? Iba kasi yung increased to sa increased by. Okay? Pag increased to, final value. Pag increased by, ito yung change. Okay? Ito yung change. Okay? So, determine the new resistance value of the material. So, let us consider for number 6. I-copy ko na lang ito, no? Para hindi na ako mag-draw ng panibago. Babaguhin ko na lang. Walang given na diameter. Okay, so let us consider initially, ito lang yung length ng ating material. Hindi binanggit kung gaano kahaba. Let us consider its initial length, that is simply L. But the initial resistance before it was drawn down again, that is only 0.8 ohm. So after by successive passes through drawing dies, ito drawing dies, ito yung ginamit na pambanat. Pero hindi siya dies na yung cube. So yung pambanat na yan, dalawang cylindrical metal rotating in opposite direction, sa clockwise at sa counterclockwise. Tapos doon siya ipiped na ipapasok mo doon yung metal. So yun yung bahalang mag-elongate or magbanat. So tawag natin sa kanila is drawing dies. So after by successive process through drawing dies, the length of the wire increased by. So increased by, ibig sabihin nun, pag kinuha natin yung percent change in length, this is equal to final minus initial L2 minus L1 over L1, i-times lang natin ng 100%. Okay? So here, the percent change in the corresponding length increased by 2.5 times its original value. So in terms of percentage, lumalabas, this is what? 250. 250%. So ibig sabihin, pag kinuha natin yung final length, L2 now, it should be equal kanina. 3.5 of initial length. Okay? Increased by, ito yung inihaba. So mas humaba siya ng 2.5 times the original value. Kaya pag kinuha mo yung ating final length, o yung ating percent change in length, that is final minus initial over initial, yung 2.5 na yun, in terms of percentage, that is 250. Kaya pag kinuha ko itong L2, cross multiply, transpose, lalabas yung ating 3.5. So this is delta L since ang term mo increased by. Increased by. Now, kapag ka ginamit is increased to, kasi iba yung increased by, pag by ang ginamit, dito tayo, it represent delta. That is the change. Okay? That is the change palagi. So, hindi naman palagi increase. Pwede rin decreased by. Basta by ang term, represent the change. Yung difference between final and initial. Now, pagka ginamit is 2, it represent final value. Yun ang difference ng dalawa. Kaya ito, baka mamaya hindi nyo pansin, ulitin ito, baguhin naman. Gawin lang, increase 2. Pag increase 2, automatic yung L2 mo, 2.5. Okay, so here, increase by, so your final length is 3.5. So ano hinahanap? What would be the final resistance? So maliwanag, the given material undergo drawn process. So therefore, under drawn process, resistance is directly proportional to the square of its length. Kaya using ratio and proportion, so kuha na natin ratio of final resistance over its initial, it should be also the ratio of what? Final length over its original length, nga lang, quantity squared. Okay? So in that case, kuha natin that the final resistance initially 0.8. Ano na si L2? That is 3.5 times the initial length. L1 is initial length. So quantity is squared. So cancel na natin si L. So kita na natin that its final value would be equal ka. So pwede natin diretsuhin. 0.8 times 3.5 squared. Yan na siya. Ano lobas? We have 9.8 ohms. That should be the answer. 9.8. Anong letter? Ayun. Anong letter ito? This should be that style. Okay, kuha? Any question regarding problem number 7? Ito na ba? Okay, number 7. Okay tayo. Ay, number 6, brother. That is still under drawn process. Okay? So, iwan ko yung problem number 6. So, let us try number 7. So, for problem number 7, a coil of wire or coil of copper wire has a resistance of 46 at 85 degrees Celsius. What will be its resistance at 35? So here, let us consider, balikan natin yung effect of change in temperature in the resistance of the material. So what would be the effect of the change in temperature in the resistance of the material? So according to George Simon Ohm, so after doing certain number of experiment, no? After performing certain number of experiment, he concluded that the effect of change in temperature in the resistance of the material found out that for those given conductor, the resistance increases as the temperature increases, but for those insulator, resistance decreases as the resistance increases. So let us consider for a given conductor. So anong ginawa niya? Kinuha niya, let us consider R1 is the initial resistance. Isang conductor ang pinag-uusapan natin, ang nagbago lang is the working temperature. So R1 is the initial resistance at T1. T1 is the initial temperature. And let us consider R2 is the final resistance at T2. So after performing certain number of experiment, he found out pag kinuha daw natin yung change in the resistance of the material which represent the difference between final and initial. Anong nakita niya? He found out that this change in the resistance of the material varies directly. He found out the different factor that affects the resistance. Unang-una, nakadepende daw yan sa initial resistance of the material. Another factor to be considered is the change in temperature. So pag sinabi natin change in temperature, that is the difference between final at saka initial. Diba? That is the change in temperature. So therefore, pag pinalitan ulit natin ng equal sign yan, so lalabas, the change in the resistance of this conductor, it should be equal. Lagay tayo ng constant. Alpha times R1 times the change in temperature. And this given alpha, ang tawag natin is the temperature coefficient, which is its given value is constant per corresponding material, but it changes with respect to temperature. Anong ibig sabihin nun? Ang temperature coefficient, nagbabago yan, depende sa temperature. Iba temperature coefficient ng copper at 20 degrees Celsius. Iba temperature coefficient at 30 degree, 40 degree, so on and so forth. Its given value changes with respect to time. But for copper, yun palagi, hindi siya magbabago for copper. Right? So therefore, pag sinubstitute natin yung value ng ating delta R, so makikita natin ngayon that finding the final resistance, it should be equal to R1 quantity 1 plus temperature coefficient multiplied kanina change in temperature. So anong sinasabi niya? Dapat itong temperature coefficient na gagamitin mo, it is also based on the temperature of your initial resistance. Ano ibig sabihin nun? Kung ang initial resistance natin is nasa 35 degree, so dapat ang temperature coefficient na to is also at 35 degree kasi ang kanyang value changes with respect to temperature. Eh sir, paano natin kukunin yon? So para makuha natin yon, itong ginawa ni George, pinlat niya yung behavior ng ating resistance. So using the X and Y axis. So using the X and Y axis, so para mas madali niya ma-analyze yung acquired data, so pinlat niya yan. So horizontal axis is the axis for temperature. Then the vertical axis is the axis for what? Resistance. So let us consider at initial temperature, sabihin natin ito, isa 1, we have the initial resistance, sabihin na lang natin ito, R1. So kunin natin yung intersection. Ito siya. Now let us consider in-increasan or tumaas yung temperature. Sabihin natin at T2, so obviously, you have the increase in the resistance. Sasabihin natin, that is what R2, nasaan yung point. So now, para mas maging specific or ang tawag dito, no? Not specific, accurate. Okay? So para mas maging accurate yung kanyang data, so kumuha pa siya ng different temperature and different resistance. So eto nakita niya. After those given experiment, kinonect niya yung mga data gathered. Then, anong ginawa niya? Connect niya lang yan. Then, extend niya. Pag-extend niya, kita niya yung kanyang graph. Tumama kanino? Kay x-axis. Okay? So, ano ibig sabihin ng ating line at the x-axis? So, theoretically, according to George, at this temperature, no, nasa negative. So, negative temperature yan. So, ang tawag niya dito sa capital T na to, absolute inferred temperature. Ano yung absolute inferred temperature? At this negative temperature, theoretically, the resistance of any material becomes zero. So, dito daw, nagsisiro yung resistance ng isang material. But actually, hindi magsisiro ang resistance ng isang material. Kasi hindi naman nawala yung kanyang length ng area at saka resistivity. Kaya tawag niya theoretically. So therefore, using this given data, anong ginawa niya? Gamit siya ng similar triangle. So yung height nito, tama ba? This is R1. Ang height nito, that is what? R2. Anong naging base nito? So ang base ng mas maliit na triangle from capital T to T1, that would be its original base. Ito yung kanyang T1. So from T up to T sub 2, this should be the base of our triangle. So therefore, using ratio and proportion, similar triangle, ano nakita niya? That ratio of R2 over R1, it should be equal to P plus P sub 2 over 1. Capital P plus T sub 1. So using similar triangle. So therefore, if this data is only based on this experiment, so ibig sabihin, pag kinuha natin yung ratio ng R2 over R1 here at R2 over R1 here, it is just the same. So equate natin ito kanino? 1 plus temperature coefficient multiplied kanina, change in temperature. So using this relation, makikita natin ngayon that the temperature coefficient at any temperature, it is always equal to 1 over capital T plus whatever the temperature. So that is our temperature coefficient, wherein capital T, ang tawag natin dito, this is your absolute inferred temperature. Ano ibig sabihin nun? That is the temperature at which resistance becomes zero. Now, etong absolute inferred temperature, hindi ito binibigay, lalo na kapag ang conductor ay common sa atin. Matanong ko lang mga kapatid, what is the absolute inferred temperature for copper? Ano value ng absolute inferred temperature ng copper? Ano value niya?
4.5, sir.
Yes, very good. No? That is 234.5 degrees Celsius. So that is constant for copper. Kaya pag copper, hindi na binibigay yan. Automatic na alam na natin yan. Okay? So ibig sabihin, either using this formula or this formula, you may get the resistance of any conductor at any particular temperature. Okay? So therefore, kay problem number 7, pwede natin i-apply yan. So kay number 7, let us just consider, walang problema kung sinong gagawin mo R1 or R2. So dapat consistent tayo. No? So let us consider that the given temperature T1, that is 35 degrees Celsius. Hindi natin alam kung ano resistance. Now, temperature increases from 35, umabot ng 85. And at this given temperature, we have found out the resistance of the copper wire is 46 ohms. So, na hinahanap what would be the value of our R1. So, either change in R or R2 over R1, pwede natin gamitin ito. So, here, mas madali nang gamitin yung ating second equation. Kasi alam na natin ano yung absolute input temperature ng ating copper. So, pwede nating baliktarin na lang itong ating equation. Instead na R2, pwede natin gawing R1 over R2. So, therefore, ito, P1 over P sub 2. So, yun na rin siya, kapatid. No? So, using the formula, pwede natin gawin R1 over R2. It should be also the same as T plus T sub 1 over capital T plus T sub 2. So, walang problema. It will be the same. Okay? So, kuha na natin yung ating R1. Okay. So, solving now for its initial resistance. Ano si R2? 46. Quantity. 234.5 plus T1 of 35. 234.5 plus ito, 85. Meron tayong final answer. What would be its final resistance? So, kindly counter check. No? 46 times 234.5 plus 35 over 234.5 plus 85 equal. Siyempre, mas maliit na yan kapatid. So, ilan siya? 38.8. Tama? Yung tama kapatid. 38.8 ohms. Ayun. Anong letter? Cuts time. Okay, go ahead. Any question regarding problem number 7? So, dalawa yung possible natin. Ito yan. Either itong value or ito. Yung nga lang, at this case, hindi natin magagamit itong equation na to kasi wala tayong temperature coefficient at 35 degree. Pag ginamit natin to, dapat yung temperature coefficient ng copper, it is based on 35 degree Celsius. So, para magamit natin ito. So, since wala data, so gagamitin natin is absolute. So, if you want to check, pwede mong kunin yung temperature coefficient at 35 using this equation. Double computations ka pa ngayon. So, unlike dito, direct substitution. Since alam natin, the conductor is copper, and for copper, it is always 234.5. Tama ba? Any question regarding problem number 7? Ngayon, in case, sir, paano po? Pag hindi binanggit kung anong klaseng conductor ito, paano siya i-solve? So therefore, ang gagawin mo, using this equation, susolve mo pa rin si capital. So, ganun din siya. Parang babalik lang tayo sa original equation. Okay? So, any question regarding problem number 7? So, iwan ko, no? Let us try number 8. So, for number 8, again, a resistance of wire is 126.48 at 100. Then 100 ohm at 30. Determine the temperature coefficient of copper at 10 degrees. Okay? Ang hinahanap, required, that is the temperature coefficient. At what temperature? 10 degrees Celsius. Okay? Kakakuha lang natin that the temperature coefficient at any temperature, it is 1 over capital T plus whatever the temperature. So, since copper yan, pwede natin 1 over, absolute input the copper, 234.5. Plus muna lang sila, 10. So, meron tayong final answer. So, the temperature coefficient, it should be 1 over 234.5 plus 10 equal. So, ito siya kapatid. You have 4.0899 times 10 raised to negative 3, per degree change in temperature. So, ibig sabihin, the resistance of this copper from 10 degrees Celsius will increase by 4 milliohms per increase in temperature. Okay? So, ito rin nahanap. Kumbaga, yung ibang data, palamuti na lang yan. Kasi alam na natin that the conductor is copper. Kaya kahit di mo na gamitin yung ibang data, makukuha na rin natin. Sagot, anong letter yan? Baligtad. Ako ba? Any question regarding problem number 8? Okay tayo kay number 8. Okay, so iwanan ko si number 8. May tanong ba mga kapatid? Number 9. Madali na ito. The voltage applied across... Uy, parang nabibili yata yung aking display. Check lang. Hindi ba delay sa inyo yung aking display? Hindi naman na-delay? Okay lang? Okay lang yung bato ng aking data?
Okay lang, sir.
Okay lang. Okay lang. Hindi naman. Baka yung aking... Baka nalolobat yung aking ginagamit na isang monitor kaya parang nadidelay sa kanya. Charge lang kita. Nadidelay yan. Okay, so let us continue. The voltage applied across electric press. Kumbaga, electric press. So, madalas sa plancha. Okay? Iron. Pang plancha, pang lapat ng damit, pang pantanggal na ng lupa. Was reduced by 50%. The power consumed by the press will reduce by. So, pag kinuha natin yung equivalent circuit ng ating electric press, so, more dominant sa kanya yung kanyang resistance. Kaya pwede natin kunin that the equivalent circuit Okay, so let us consider that will be the equivalent circuit for our problem number 9. So we have electric press wherein mas dominant yung kanyang resistance, kaya pwede natin consider that is purely resistive. That is connected across a variable voltage source. No? Meron tayong arrow for the battery that represent its value is variable. Then alam naman natin for any given source. No? So for battery, so practical battery, meron tayong tinatawag na internal resistance. If you try to compare the value of your internal resistance with respect to the resistance of the load, so most of the time, internal resistance is very much negligible. So sobrang liit niyan. Kaya pagka hindi binanggit, ang ating assumption is ideal source. Pag ideal source, the internal resistance, it is what? Negligible. So let us consider at this case, ideal source. So internal resistance is approximately 0. So therefore, we have now the circulating current here. So let us consider, sabihin natin, initial source voltage is equal to the rated voltage E. The power consumed, P, it is just simply equal. Sabihin natin is V. So let us consider, binago natin yung ating source voltage. From E1, let us consider E sub 2. Anong binanggit? Reduced by 50%. So therefore, the final value, it should be now only 0.5 of the initial value. Reduced by 50%, kaya remaining is only 0.5. So ano hinahanap? Required. What would be the change in power? So pagka-reduce yan, so lalabas dito negative. Okay? So pagka-increase yan, So lalabas diyan positive. Kasi itong percent change, pwede yan positive or negative. Pag positive, increase. Pag negative, decrease or loss. So therefore, para makuha natin the amount or the change in power consumed or delivered to our electric press, kailangan natin kunin what would be its corresponding power consumption if the voltage is what? Reduced by 50%. So lumalabas, the change in power that is just equal to P2 minus P1 over what P sub 1. I-types na natin na 100%. So pag negative, reduce yan. Pag positive, increase yan. Tanong, paano ba kunin yung power? Alam natin, power in DC, that is just the product of voltage times the current. No? Kasi alam natin, power, real power, ang unit niyan, that is only watts. Ano nga ba si power? Pag dinefine natin si power, dyan sa ating physics, power is the rate of doing work, not the rate of doing work, or that is the rate at which energy is being consumed per given time. So energy represent that is the joule per second, based on its definition. So that is the given power. Kaya kung babalikan mo, ang unit ng E is voltage, which is what? Joule per coulomb, at ang current is the intensity, that is the coulomb per second. Pag multiply, cancel yung coulomb, matitira joule per second, and the unit is watts. Now, alam naman natin, by Ohm's law, your E is also I times R. Kaya pwede natin sabihin, I is squared times also the resistance. And also, using Ohm's law, I is E over R. So pwede rin natin gamitin. That is the source voltage is squared over the resistance of the circuit. So that will be our general formula for power. So since hindi naman natin binago yung ating load resistance and the given internal resistance is negligible since ideal source tayo. So resistance of the circuit is held constant. So therefore, pwede natin sabihin at R. Bakit ayaw na magsulat? Okay, so at R, it is held constant. Hindi na constant ang itsura. Sulat ko. Ano pwede na sabihin? Power, it is just directly proportional to the square of the given voltage at R is constant. So again, using ratio and proportion, so using same idea, ratio and proportion, so pwede natin kunin ratio of final power consumed by the electric press over the initial. It should be equal to the ratio of final over initial voltage supplied to its terminal. Yun na lang, quantity is squared. So at this case, pwede na natin kunin that its final power in terms of the initial power is a 1, quantity, ano yung ating final voltage, that is 50% of the initial voltage over initial voltage, quantity is squared. So pwede natin i-cancel itong source voltage. So what would happen to our final power? So therefore, the power or the final power consumed by this given load, it is now only 0.25 of the initial power. Okay? So from 100%, the power consumed by this given load reduced to 25%. Eh, hinahanap natin how much power is reduced. So P2 minus P1 over P1, or simply kahit hindi ko na idaan sa equation na yun, obviously the change in power is what? 75. So pag sinubstitute natin dito, lalabas dyan negative. So negative represent the power is reduced. Eh nasa statement na power is reduced, kaya sa choices, wala nang negative. So na hinahanap natin, reduced by, so that is at what? 75%. Nakuha ba? Pero kung ang tanong dito is reduced to, kung TO, ito, the answer should be what? 25. So since reduced by, so decreased by 75%. Nakuha ba? Any question regarding problem number 9? No? So that is only power formula. So galing lang dito sa ating 8 times I. Yan naman palagi yung ating power. Okay? So any question regarding problem number 9? So you want to see number 9? Let us try number 10. No? The voltage at the terminal of a battery falls from 13 volts on open circuit to 12 volts when the resistance of 10 ohm is connected across its terminal. So what is the internal resistance of the battery? So for problem number 10, pag kinuha natin yung equivalent circuit ng battery, so for practical battery, kung binanggit natin, yeah, lahat. Meron yan palagi internal resistance. With its equivalent open circuit voltage, E. And this is R. So at open circuit, ibig sabihin, wala tayong load connected. So ito yung kanyang terminal. No? This would serve as its terminal for the load side. So kung kumuha tayo ng voltmeter, tinap natin dyan. Okay? Alam natin voltmeter. Okay? So kumuha tayo ng voltmeter, anong naging reading? So based sa problem, that is 13 volts. So that 13 volts, no, kapag wala tayong load connected dyan, so the voltmeter or the voltmeter reads here always represent that is the rated voltage of our battery. So that is what? 13 volts. Kasi alam natin, pag kinuha mo equivalent circuit ng ating voltmeter, so meron niyang shunt resistance or internal resistance. Eh, ang internal resistance ng ating battery, eh napakalaki nun, no? Approaches to infinity. So therefore, pag kinonect natin dyan, comparing the internal resistance of the battery to the shunt resistance or do sa equivalent resistance ng ating voltmeter, so napakaliit nito. So usually less than 1 ito. Tapos itong voltmeter, infinity mega ohms. Kaya lumalabas, negligible ito. Kaya ang masusukat mo doon, that is only the voltage drop or the open circuit voltage ng ating battery or its corresponding rated voltage. So that is 13 volts. So buka natin using open circuit, that is the terminal voltage of our battery. So pinipag ko muna siya dito. So after natin kunin yung kanyang open circuit voltage, nag-connect na tayo ng load. So let us consider this will be our load resistance. Ano value? So that is only 10 ohms. So nung nilagay na natin yung ating load voltage voltage or load resistance of 10 ohms, ganun din. Tinap ulit natin si voltmeter sa terminal. So therefore, ito at saka yan the same. So kinuha natin ngayon ulit ang reading. So the reading of this voltmeter from 13 volts on open circuit habang wala ito, nung kinonect natin si 10 ohm, nag-read na lang siya as 12 volts. So ibig sabihin, at this case, the voltage reading of our voltmeter represent the voltage drop across the load side. Kasi pag may load na tayo, lalabas, yung equivalent resistance ng ating voltmeter, it is now in parallel with your load resistance. Alam natin, pag parallel, voltage, it is just the same. So therefore, the voltage drop across 10 ohm resistance, it should be what? 12 volts. So ano hinahanap? What would be the internal resistance? R. Okay? So since nakuha na natin ang reading, tanggalin na natin yung voltmeter. So pag tanggal natin kay voltmeter, kita natin we have only one, a series circuit. So alam na natin, pag series circuit, pag kinuha natin ang total opposition over to the flow of current ng ating circuit, so at series circuit, that is only the summation of individual resistances. So dyan sa ating illustration, dalawa lang yan, that is the internal resistance plus load resistance. At alam natin, by Ohm's law, resistance, it is equal to voltage over kanino, total current. At alam natin, for series circuit, so the current in every resistance are just what? The same. So wala nang problema, makukuha natin ngayon that the corresponding internal resistance, it should be equal to source voltage over the total current minus the load resistance. Okay? So wala na problema. Ano source voltage natin? That is 13. Ano ang current? Saan natin kukunin? Since series circuit, current it is just the same. So using the voltage drop across the load resistance, so pwede natin sabihin that this voltage drop by Ohm's law, that is just the product of current times kanino, RL. So therefore, pwede natin sabihin this is 12 divide kanino, 10. So that is the current. Minus na lang natin na 10. Meron tayong final answer. Ano lumabas kapatid? Can you count for check? 13 divided by 12 over 10. Minus 10. Ano lumabas kapatid? Yun, 0.83 ohms. Nakuha ba? So that is 13 over 12 over 10 minus 10. So 5 over 6, or that is 0.83 ohms. Yan ang hinahanap ng ating problem. Ang letter, ayun, sakto. Baligtaran. Ako ba? Any question regarding problem number 10? Simple lang. Simula nung maging 100 items yung ating board exam, more on basic principle. So, alam natin, madali yung magiging experience natin sa pag-take ng board exam kung tama yung preparation. Diba? Pag alam mo yung basic principle, medyo tama yung preparation mo, syempre, so tingin mo, lahat ng problem, dahil ready ka, tama preparation mo, syempre, madadalian ka ngayon. Pero kung ikaw kulang ang preparation, hindi ka naganda. So kahit simple yung problem, paglimot mo yung formula dahil hindi ka nag-ready, hindi ka nag-review, so obviously, lahat ang tingin mo, lahat ng problems mahirap. Kaya kapag tinanong mo yung bumagsak, kapatid, kamusta board exam? Mahirap. Kasi kulang ang preparation. Pero pag tinanong mo yung pumasa, sakto lang, sabihin sa iyo. Pero pagka tinanong mo yung nag-top toucher, madali. Kasi okay na okay yung kanyang preparation. So, ganun lang naman ang labanan. Pagdating sa exam, kailangan lang palagi ready ka. Prepared ka. No, kahit sa anumang larangan, kahit anong discipline. Kung gusto mo madalian at di mahirapan, syempre kailangan mo mag-ready. Kahit naman mga athlete, di ba? Kahit mga professional na yan, kahit magagaling na yan, pero bago sumabak sa isang game, di ba? Tuloy-tuloy pa rin ang kanilang practice. Practice game. So, ganun din tayo, kapatid. Para habang hindi pa tayo sumasalang dun sa actual game natin, kailangan continuous na yung ating preparation. Nag-start na tayo ng preparation. Ngayon, nag-start na tayo ng preliminary preparation. So, tuloy-tuloy lang natin yan. Sigurado pag tayo na sumalang sa laro, kayang-kaya mo na. Yeah, gano'n lang naman. Okay? So, any question regarding problem number 10? One question number 10, ano? Kayang-kaya, simple-simple. Number 11. So, for number 11, we have two bulbs. So, alam natin, for bulbs, so that is expressed by, or that can be expressed in terms of what? Simple resistance. Now, two bulbs rated 150 and 200 watts. If two bulbs are connected in series across 240 volt source, what resistance is required so that two bulbs will operate normally? So let us consider, hindi binanggit kung ano internal resistance ng ating source. So let us consider ideal tayo, ideal voltage source. So kapag kinuha natin yung equivalent circuit, initially mo ating condition. For two bulbs, usually, the equivalent circuit ng ating bulb is purely resistive. Ano? So let us consider ideal voltage source. So this is 0. So let us consider our rated voltage E. Initially, this is what? 120 volts. So 2 volts, pwede natin express as what? Simple resistance. So let us consider ito si bulb A, ito si bulb B. So initially, when they are connected across 120 ideal voltage source, so the current here, sabihin natin I sub A, current here is I sub B. So initially, they are connected in parallel, and we have found out that the power absorbed by bulb A, that is 150 watts. But for bulb B, P sub B, sabihin natin, that is 200 watts. So let us consider, ginamit na natin yan. Unfortunately, na-discharge na yung ating battery. Okay? So fully discharged na yan. Kailangan pa rin natin ng ilaw. So fortunately, meron tayong backup source. Medyo problema lang, from 120 volts na required ng ating dalawang ilaw, yung ating backup battery, that is now 240. So ngayon, ang ginawa natin, dahil 240 yan, so our initial, isiris natin yung dalawang bulb. So we have two bulbs now connected in series. So again, internal resistance of our source battery is still what? No? 0. So ideal voltage source. Nga lang, it is now rated 240. So meron pa rin tayong same bulb. Hindi nagbago yung resistance ng ating bulb. So ito hinahanap ng problem. So in order to operate these two bulbs at 240, hinahanap what value of resistance is required so that these two bulbs will operate normally. Ano ibig sabihin na operate normally? So in order to operate, no, in order for this bulb operate normally at 240. So dapat kung ano yung kanilang rated current, kay current pa lang din tayo magbabasa doon. So dapat kung ano yung current supplied to them when they are connected to the rated voltage. So dapat kung anong current ito na dumaan kay A, yun din dapat ang current dito. So kung anong current dumaan kay B, yun din dapat ang current dyan. So dapat, ang current natin pa rin dito, current passing through RB, it should be IB. At yung current passing through bulb A, it should be IA. Eh alam natin, sa series circuit, dapat iisa current. Eh alam na natin, based on their given power, magkaiba ang value ng IA at saka IB. So, ito yung pinaka-concept. So, paano natin ma-maintain yung current IA at IB when they are connected in parallel when they are now connected in series? Kailangan, kung ano ito rin yan. Kung ano ito rin yan. Kaya kailangan, meron tayo additional resistance. So, yun ang hinahanap ng problem. What should be the required resistance to be connected in the circuit in order for this two bulb operate normally? So, unang tanong dyan is, paano natin i-connect itong required resistance? Sigurado, hindi na siya series. Okay, bakit sir? Kasi nga, pag series yan, hindi na natin ma-attain itong magkaibang current kasi isang current na sa series. So, meron ka ng idea, dapat itong required natin ay nakaparallel. Kanino natin siya ipaparallel? Kay RA ba o kay RB? So, para makita natin kung kanino siya nakaparallel, i-compare natin yung current IA at IB. Okay? Compare natin. So, kung sino yung mas maliit na current, sa kanya dapat nakaparallel. Okay? So, kung sino mas maliit na current, sa kanya dapat nakaparallel. Sir, bakit? So, tignan natin. Ano? Kapag kinuha natin si IA, using power formula, you have the power, you have the voltage. Since ideal tayo or parallel, whatever the voltage structure, that is also equal kanina, source voltage. So using the power control of bulb A and the supply voltage, makuha natin si IA. Ano si IA using power formula, 150 watts, i-divide natin kanina, 120. So this would be 15 over 12 na lang. So ilan siya? 5 over 4 or this is 1.25 ampere. Then solving for IB, its power is 200 over 120. So 200 over 120, so ilan naman to? 5 over 3 or that is 1.6 is 7. So ibig sabihin, mas malaki ang value ng current IB. So alam kasi natin kapatid, okay? So kapag nag-parallel tayo, ang current ma-divide. So in that case, para ma-divide itong current kay IB, kailangan mag-connect tayo ng resistance in parallel with RA para yung dadaan na current sa kanya lumiit from 1.67 to 1.25. Lumalabas ngayon, pag nag-connect tayo ng resistance in parallel with RA, ibig sabihin, yung current kay B, it would serve now as our what? Total resistance or total resistance, right? Total current in this given circuit. Kaya if this is total current, this also your total current, it should be equal kanino? IB. So 1.67 ang total current. Pagdaan yan, so parallel ito, alam natin, at parallel current will be divided now. Kanino siya? Mali-divide siya kay IA at saka dun sa current in the unknown resistance. Let us consider this is your IA. Okay? So, pagpasok ni IB, hati siya kay IA at saka kay I1. Pag enter this node, lalabas na rin sa IB. So, kapag parehas na yung current na dumaan kay RA in terms of 120 at 240 volt source, and same also for RB, no? Pag parehas na yung current dyan, so this two bulb will now operate normally. Kasi parehas na yung current. Hindi nagbago yung current from 120 volt source to 240. So what would be the value of this R? Okay? So lumalabas, si I sub 1, applying KCL here. Sir, ano po si KCL? Kirchhoff's current law, current entering should be equal to current leaving. Lumalabas, this is equal kanino? I sub B minus what? I sub A. So wala tayong problema kanino? I1. Sir, paano po yung ating resistance? By Ohm's law. Since this R is in parallel with RE, so therefore, kung itong resistance na to, ito rin yan, at ang current na to is IA, at ang current dito is IA, tama ba na ang voltage drop dapat dito, it should be what? 120. Gets? Kasi parehas daw naman to. So, I times R is voltage, which is E. I times R, that is voltage, which is equal kanina, 120. So, ibig sabihin, kung 120 ito, ano rin ang voltage drop nito? 120, since they are connected in parallel. Tama ba? So, therefore, okay na. Solving now for the unknown resistance in parallel with RA, it should be equal. Ano voltage dapat sa kanya? 120. Anong current dapat sa kanya? It should be 1.67 minus 1.25. So, meron tayong final answer. Ano lobas kapatid? This is 120 over answer minus 1.25. So, you have 200. So that should be the resistance required so that this two bulb will operate normally. Kanino natin siya ipaparallel? Kay RA. Kasi mas mataas ang current ni IB. So it represent yung current natin kay IB, it would serve the total current in the circuit so that pagdaan doon kay RB, parehas na yung kanyang required current. Eh since mas maliit ito, alam natin, para lumiit yan, mag-add tayo ng resistance. Ano? So para ma-by parts, mahati yung ating current into IA at saka I1. So in that case, solve natin si R. Nakuha ba kapatid? Gets natin kung saan kinuha itong 120? Since nakaparallel kay RA yan, so ano man ang voltage drop dito kay pag equal sa voltage drop across this R. So saan natin nakuha yung voltage drop? So since ang condition dapat itong current na to at saka yan equal, so if these two current are equal, hindi naman nagbago ang resistance. Therefore, initially, ang voltage drop here is 120. So therefore, the voltage drop here is also 120. Kaya kapag kinuha mo, voltage drop here is 120. Therefore, the voltage drop here is 120. So pag pinag-add natin, ilan siya? 240. Nakuha ba? Any question regarding problem number 11? Anong letter yan? So this should be baligtaran. Okay, kuha? May tanong ba kapatid? Any question regarding problem number 11? Kasunod? So, simpleng circuit analysis lang, no? Okay, any question before tayo mag-coffee break? May tanong ba tayo kapatid? Sir, bakit nga siya sa RA nilagay? Yes, okay. So, bakit siya kay RA? Kasi alam natin, pag series yan, habang wala ito, iisang current. So, mas malaki yung current requirements ni RB compare kay RA. So, therefore, para mas lumiit yung current na dadaan kay RA, which is 1.25. So, itong current ni B, kailangan mabawasan natin. Okay? Kailangan mabawasan natin kasi ang current sa kanya is 1.67, eh kay IA is only 1.25. So, therefore, kailangan natin magdagdag ng resistance na kaparallel kay RA para ano mangyari, mabawasan itong current na to. Diba? Kailangan ang current at resistance inversely proportional. So, ipaparallel natin para ibang portion ng ating 1.67, ang tawag natin ngayon dito is diverter resistance. Dinivert natin yung portion of the current ni IB para ang matira lang sa kanya is what? 1.25. Kasi 1.25 ang kanyang required current. So, dapat dito tayo maglagay ng diverter. Kasi kung dito tayo maglalagay, kapatid, kung dito tayo maglalagay, so if you try to look, dito ka maglagay, so lalabas yung ating total current 1.67 plus yung current IR, which is very much greater than kanino, 1.25. So lalong susunod yung ating bank A. Nakuha ba? So para isang resistance lang tayo, whatever the higher current, yun ang magiging total current dapat sa ating series circuit. So para lumiit yung current kay RA, maglagay tayo na diverter resistance. Okay? Okay, so any more questions, kapatid, regarding problem number 11? Gets na natin? Okay, so kung wala nang tanong, merienda muna tayo, kapatid, no? Coffee break, 15 to 20 minutes will do. So after that, resume natin, ano? Mga 3:20, resume natin. Merienda lang tayo, kapatid. Okay? Sige, balik tayo ng 3:20. Okay, good afternoon again. So let us continue. Tuloy lang natin yung ating discussion. So let us try problem number 12. So for number 12, no, we have three resistors with 10, 12, and X ohms are connected in parallel across a current source of 8 ampere. So determine the value of X if this resistance draws 2.5 ampere. So let us try to consider for problem number 12. Kunin lang natin yung equivalent circuit. Ito pa yung so let's consider this would be our 10 ohm resistance. So this is 10, this is 12, and we have a known resistance that is considered Rx. So we have a current source, so therefore whatever the current source, it represents our total current here. So based on problem, no, the total current that is only 8 ampere. So what would be the value of our Rx if the current passing through this unknown resistance that is considered that is I sub x, which is only equal to 2.5 ampere. So how to solve for the value of Rx? So here, since we have parallel circuit, para mas madali natin ma-solve yung value ng ating Rx, so let us consider, no, gamit tayo ng current divider theorem. So using CVT, yun nga lang, no? The current divider theorem, although that is based on Ohm's law, yun nga lang, yung kanyang analysis ay nakabase sa two resistance connected in parallel. So let us consider okay, so we have two resistance connected in parallel across, sabihin natin kahit sinong voltage source yan or current source. Have the resistance here. So let's say the total current here, let us say I total. So let's say this would be our Rx na lang, and this should be our R sub Y. So therefore, the current in every runs here, let us consider that is Ix. and the current here, that is IY. So current divider theorem, that is only based, no? Nakaderive pa rin yan using Ohm's law. So hindi ko na lang i-derive. So therefore, pag kinuha natin yung current across Rx, so that is always equal to whatever the total current multiplied to the opposite resistance Ry, i-divide natin kanino? Rx plus Ry. So that would be our I sub x using current divider theorem. Kasi galing lang din to in terms of Ohm's law. So kapag kinuha natin si Ix, that is the total voltage or the voltage drop across Rx over its resistance Rx. Eh alam natin for parallel, whatever the source voltage equal to the voltage drop here. So you may get by Ohm's law, total voltage is total current over the total resistance. So pag sinubstitute mo, ito na ang makukuha nating equation. So therefore, para magamit natin yung current divider theorem, so pwede muna natin i-simplify itong ating two given resistances since nakaparallel sila. So pwede natin i-combine itong 10 at saka 12 into single resistance. At sabihin natin, the resistance, the equivalent resistance of 10 and 12 in parallel, that should be our R sub Y. So kapag nakuha natin si R sub Y, ito na yung ating magiging equivalent circuit. So in that case, solve na natin yung value ng ating R sub X. So if we try to get R sub Y for parallel, i-parallel na lang natin si 10 raised to negative 1 at saka si 12 raised to negative 1 plus quantity raised to negative 1. So that is equivalent parallel value. So 10 inverse plus 12 inverse plus quantity inverse. So that would be our total resistance for R sub Y, 60 over 11 ohms. So therefore, using the current divider theorem or yung CDT, so we have Ix which is 2.5, we have Ry, cross multiply. So therefore, Rx now, it should be ano yung total current? 8. Ano si R sub Y? 60 over 11. I-divide natin, Ix given is 2.5. Sa dulo, minus R sub Y is 60 over 11. So we have now Rx. Na siya kapatid. So I have 8 times the answer divided by 2.5. Then minus ko na lang yung ating answer. So therefore, unknown resistance X, that is only 12 ohms then. Anong letter yan? Ayun. Nakuha ba? Any question regarding problem number 12? So that is only based on current divider theorem. At si current divider, derive lang yan, again, using ohms. Okay? One goes to number 12. So let us try number 13. A 12-volt battery with 0.05 ohm resistance, so it represents that would be its internal resistance. And another 12-volt battery with internal resistance of 0.075 ohm resistance supply power to a current through the load. So let's say we have two battery connected in parallel. Kunin na lang natin yung equivalent circuit. Okay, so let us consider, no, that would be our equivalent circuit. We have two battery with their given internal resistance are connected in parallel to supply a common load. So based on problem, the open circuit voltage for these two battery, E1 and E2, are just equal, which is 12 volts, wherein the internal resistance for the first battery, that is only 0.05 ohms, and the internal resistance for the second battery, given naman, 1.75 ohm. So these two battery are connected in parallel to supply a common load. Let us consider load resistance is 2 ohms. So ano yung nahanap ng problem? What would be the current? What would be the current in the load resistance? So let us consider that should be our IL. So saan natin kukunin yan? So let us consider the current supplied by the first battery towards the load. Let us consider that is what I1. And the current supplied by our second battery, let us consider that is what I2. So very obvious, applying KCL at this given node, sabihin natin node A. So makikita natin that under KCL, current entering equal to current leaving. Ano? So that is I1 plus I2 equal to I sub L. So in this case, since we have two active sources, so pwede tayong gumamit ng different methods of network analysis. So depende sa iyo kung ano yung kabisado mo. Pwede kang gumamit ng Maxwell-Mesh, Kirchhoff's Law, nodal analysis. So pwede kang gumamit ng Thevenins, ng Norton. So depending kung anong gusto mong gamitin. Pwede rin tayong gumamit ng superposition. So we have several methods of network analysis. So at any given time, pwede mo silang gamitin kahit anong method, iisa ang lalabas na sagot. But obviously, per corresponding method, meron tayong advisable methods na pwedeng gamitin per corresponding situation or per corresponding network. So tulad dito, for parallel network, ang pinakamabilis na gamitin ay tinatawag nating nodal analysis. So si nodal analysis, it directly compute the node voltage. Now, sino yung node voltage na yon? That is the voltage between a positive node and common node. So pag sinabi kasi nating node, di ba? Ano ba yung node? That is a junction of 3 or more circuit parameters. Now, a junction is considered a node kapag meron tayo 3 or more parameters connected to it. So tulad dito, R1 connected at node A, RL is connected at node A or junction A, then R2 is also connected at junction A, so this is considered as node. So another node, yung ating common node o yung negative node. Sabihin natin, this is at node B, since that is connected at negative terminal. So using nodal analysis, directly, masosolve niya yung ating voltage at the node.
Sir,
So, yes.
paano
Yes.
nalaman, sir, na parallel, sir?
Okay. Base here, two battery. What is the current through the load? So, iisa lang yung ating load. No? You have 12-volt battery on resistance and another 12-volt on supply power. Supply power to a common load of what? 2 ohm resistor. Okay? So, ibig sabihin, parehas gagamitin natin itong dalawang battery na to to supply electrical power to this corresponding load. So, in that case, in that base or in that particular terms na ginamit, supply power. Now, these two battery will use to supply power to a 2 ohm resistor. So, we have what? Parallel circuit. Kailangan mag-supply sila. So, ngayon, pagka series yan, so ibig sabihin, kinonect lang natin yan in series or end to end. So, iisa lang yung magagamit nating battery to supply power here. Okay? So, in this case, since given naman yung kanyang internal resistance, and both of them are used to supply power to a common load. Common, kasi common. So, pag common, ang load ng ating E1, SC2, ang load natin ng E2, that is also the RL. So, in that case, we are dealing with parallel circuit. Connected at two common point. And the two common point, kasi ito yung lalabas na terminal ng ating dalawang battery. So this is positive, negative, positive, negative. So pag parallel, you have two common point of connection. So doon natin kinonect yung ating load. Kaya lumabas, we have parallel circuit. Okay, so for this parallel circuit, since we have two active sources, so pwede nating gamitin yung different network analysis. Marami tayong network analysis. Pwede kayong gumamit ng Maxwell-Mesh, Kirchhoff's law, okay? Nodal, superposition, Thevenin's, Norton. So depende kung alin na gusto mong apply. But basically, for parallel network, pinakamabilis gamitin yung ating nodal analysis. Since under nodal, it directly compute the node voltage or the voltage between two corresponding nodes, between positive node and the negative node. So for this case, kung meron tayong parallel circuit that contains two nodes only, kung dalawang nodes lang yan, si nodal analysis, it is now converted by what? Millman's theorem. So kasi si Millman's theorem, that is only directly based on nodal. So paano ba si Millman's theorem? Actually, the nodal analysis or the Millman's theorem. Nodal, pagka meron tayong 3 or more nodes, that is direct nodal. Ngayon, si Millman's is a special case ni nodal wherein if the available node sa circuit, meron lang tayong dalawa. So kung dalawang node, ibig sabihin, isa doon yung positive node, yung isa is common node. So at that case, your nodal will be reduced into Millman's theorem. Pero the analysis for your nodal, it is based on what? Kirchhoff's law. Paano? So mag-apply lang tayo ng KCL at node A. So kung kukunin natin si Millman's theorem, which is based also on nodal, KCL tayo, KCL at node A. Anong makikita natin? Ano? You may clearly identify that the value of your I1 plus I2, it is equal kanino? IL. So, in terms of Millman's, ang sinusolve niya kasi agad is the voltage between the nodes. Kapag nagsukat tayo ng voltmeter dyan, makukuha natin yung voltage drop dito. So, to get now the value of voltage here, express the current in terms of voltage. Paano natin express itong current in terms of voltage? So, gagamit naman tayo doon ng KVL. Okay? Apply KVL here at loop 1. Same also, apply tayo ng KVL at loop 2. Anong sinasabi ng KVL? So, KVL, Kirchhoff's voltage law, that the summation of source voltage and the voltage drop within a loop are always equal. So, sign convention, kung saan lalabas yung ating arrow, doon sa polarity ng ating voltage, so it should be positive. Now, with respect to the voltage drop, compare mo sa direction ng current. Same direction plus, or same direction minus, opposite direction plus. So therefore, the current that would pass at R1 is I1. So kapag place natin, it would be same direction as our loop direction. So the voltage drop across R1, it should be minus. Then, the voltage drop across load resistance, kapag kinuha mo ang direction ng current with respect to loop 1, so that is also this. So therefore, i-minus natin yung voltage drop across this RL. So lumalabas, KVL at loop 1, you have now equal kanino? Source voltage minus the voltage drop across R1, which is I1 times R1 minus voltage drop across RL, which is our load voltage, B sub L. Equate natin sa 0. So, makikita mo ngayon that the value of I1 it should be equal to E1 minus VL, i-divide natin kanino? R1. So that is your I1 in terms of voltage. So same idea to solve for I2. KVL at loop 2. Anong makikita natin? Source voltage E2 minus the voltage drop across R2, which is I2, R2 minus the voltage drop across load side, that is V sub L, equate natin kanino? 0. So, makukuha natin yung value ni I sub 2, which is, again, E2 minus V sub L i-divide kay R2. So, may I2 na tayo. At alam natin, load current by Ohm's law, GL over RL. Kaya pag sinimplify natin, ito, substitute mo doon. Pasok mo dyan. Tapos ito, pasok din natin dito. Okay? So, makukuha natin ngayon yung load voltage. So, yun yung goal ng ating nodal. At kapag sinodal, it contains two nodes. Nodal, it is now reduced into Millman's theorem. So, pag ito, sinubstitute ko rito, ito, sinubstitute ko dyan, si IL, pinalitan ko as BN over RL, then solving for your V sub F, ito na yung general formula ng ating nodal analysis. So, under nodal, wherein nodal has two nodes, it would be now Millman's theorem, which is used to directly solve for the voltage at the load side. It should be only equal to sa taas, summation of the ratio of your EMF over internal resistance. Sa baba, that is just the summation of the reciprocal of internal resistance at saka sino, load resistance. So yan na yung general formula ng ating load voltage using Millman's theorem. Kaya kapag nakalimutan mo ito, so pwede ka lang bumalik sa simpleng network analysis. Ano lang ginamit natin? KCL and KVL. So that is our Kirchhoff's law, which is divided into current law at saka voltage law. So that's the idea in getting the node voltage under nodal kung meron tayo 3 or more nodes. Pero kung dalawa lang, automatic, nodal analysis, it is reduced to Millman's theorem. Ang makukuha nating node voltage, that is directly the load voltage. Nakuha ba? So ito, no? Pag sinubstitute mo, then getting sub L, ito yung ating magiging general formula. So this would be the formula in solving the load voltage using Millman's theorem. Kailan mo magagamit si Millman's theorem? So that is for parallel circuit that contains two corresponding nodes. So pag alam na natin si load voltage by Ohm's law, kuha na natin si IL. Okay? So therefore, solving now for the load voltage, V sub L, dalawa lang yung ating source voltage. So E1, which is 12, i-divide natin kay R1, 0.05, plus another voltage of 12. Its internal resistance is 0.075. I-divide natin sa baba, 1 over 0.05 plus 1 over load resistance is 1 over 2. So, kuha natin si load voltage. Okay? Check natin, 12 over 0.05 plus 12 over 0.075. Sa baba, 0.05 inverse plus 0.075 inverse plus 2 inverse. So, kailangan yung ating load voltage, it should be less than the internal or EMF of our battery. So, ano ba? Ang napindot ko. So, kinukuha ko 11 point, sabihin na lang natin, 82 volts. So, therefore, solving now for your load current IL, it should be ohms na lang, 11.82 over 2 ohms. So, we have now the answer. Divide by 2. So, meron tayong 5.9 ampere. That should be our answer. 5.91, anong letter? This should be dog style. Okay, nakuha ba? Any question regarding problem number 13? So at the same time, alam naman natin, practically speaking, if we have two or more sources given, unless otherwise, babanggitin na rin naman ng problem if those given sources are connected in series. But kung wala yung specification that they are connected end-to-end, automatic, the assumption is what? Parallel. So, kailangan nakapag-even sa mga generators. So generators represent our source voltage. So wala pang nag-connect ng generators in series. So depende na lang siguro sa specific application. But basically, if they are going to use to supply a corresponding amount of electrical power or electrical energy, unless otherwise specified, they are always connected in parallel. Okay? So pwede naman tayong mag-connect ng series, but definitely, depende na lang dun sa ating application. Okay? So, isi-series natin yan kung the given application requires low voltage or high voltage but low current. Okay? So, high voltage but low current, so you have to connect them in series. Pero kung kailangan natin is low voltage at high current, you have to connect them in terms of what? Parallel. Okay? Kaya kung babasin mo, if you try to observe sa mga planta, kung meron tayong 2 or more generators in the given plant, hindi na tinatanong kung anong connection mo. Automatically, they are always connected in parallel. Okay, kaya dito, pag hindi binanggit, pag sinabi lang, used to supply a common load, automatic, they are always in parallel. Okay, yan ang palaging default or assumption na connection ng ating 2 or more active sources. Okay, babanggitin din sa atin ng situation or ng problem kung isi-series ba natin or parallel. Pero pag walang specification, automatic, they should be connected in parallel. Okay, ko ba? Any question regarding problem number 13? So that is only using Millman's theorem. So kung ayaw mo si Millman's, pwede ka rin gumamit ng Maxwell mesh analysis. So we have two loops here. Maglo-loop tayo using mesh analysis. So lalabas dyan, two equations to ano. After mo makuha si I1 at I2, babalik ka kay KCL. That I1 plus I2, that is equal to I sub n. It would be the same also. Ay, po ba? So any question regarding problem number 13? So ang ginamit ko na lang dito is using Millman's theorem. Since the circuit, it is just what? Parallel circuit. Okay? Any question regarding problem number 13? Kasi kung isi-series natin yan, so voltage should be additive. So therefore, lumalabas by Ohm's law, 24, i-divide lang natin sa 2 plus 0.05 plus 0.075. Yan yung magiging load current natin. Anong lumabas? 11.29, which is wala rin naman sa choices. Tama? Gets ba? Okay, so any more questions regarding problem number 13? So Iwan goes in number 13. So for number 14, we have a lead storage battery which is rated 12 volts. If the internal resistance is 0.01 ohm, what is the maximum power? So kunin natin yung simple equivalent circuit for problem 14. So let us consider you have the given source in terms of battery. So we have practical voltage source. So ibig sabihin, you have to consider the internal resistance. And we have the corresponding open circuit voltage. Then we have a load resistance. So for simplicity, we have a single load connected across this given battery. Now, lalagyan ko lang ito ng arrow. So that arrow represents that our load resistance is variable. Kasi alam naman natin, reality, practically speaking, yung ating load is variable. No? Iba ang load requirement sa umaga, sa tanghali, sa gabi, at madaling araw. Tama? So let's say ngayon, summer, so mas mataas yung load expected natin, lalo na pagkatanghali hanggang hapon. Dahil sa sobrang init, so kailangan naka-open. No? Kung may aircon, usually naka-open aircon, lahat ng fan open. So medyo mataas yung load requirements. Pero pagdating ng madaling araw, medyo malamig, so magbabawas tayo ng different loads. So in that case, load is variable. So this R represent our resistive load. So may arrow siya. So that is variable. So in this case, we have now a circulating current here. So therefore, pag kinuha natin yung ating current, so using this simple series circuit, by Ohm's law, current is equal to total voltage over the total resistance, which is your RL plus what? R. So therefore, pag kinuha natin yung power absorbed by our load resistance, so using Ohm's law, that is only I squared times kanino, RL. So anong gagawin na lang natin? So itong current na to, i-substitute natin dito. Ano magiging equation natin? So after the substitution, we can have now E squared times RL. I-divide na lang natin kanino. RL plus internal resistance, 1E squared. Okay tayo dyan, ano? So, kinuha ko yung equation ng current by Ohm's law. Then, using power formula, so sinubstitute ko rin si current. So, we have now the power in terms of this equation. Now, let us consider that the source voltage is held constant. Okay? So, at E is constant. Hindi naman natin binago. If you try to look, constant yung ating source voltage. So, anong pwede natin sabihin? Since load is variable, as load changes, tama ba, it would directly affect the power supply or the power consumed by our load. Pag nagbago itong RL na to, tama ba, magbabago ito. Okay? So therefore, kung gusto nating i-maximize yung power absorbed by this load resistance, kung babalikan natin yung idea for maximizing the amount of our independent variable with respect or the maximize the value of our dependent variable with respect to independent. So pag sinabi natin dependent, so yung power absorbed by the load ay nakadepende to the value of our load resistance wherein alam natin this value changes depending on the corresponding time. So therefore, kung gusto natin i-maximize ito, ano sinasabi ni calculus? Maximizing the power delivered or the power consumed by the load, it should be take the derivative of this given power with respect to load resistance. Tapos ano gagawin natin? We just equate it to 0. So kapag differentiate natin ito, babalikan mo na lang, recall natin doon sa iyong differential calculus, derivative with respect to x ng ating quotient, u over b. Ano nga numerics natin yan? You have b du minus u db over what? B squared. Yun ang gagamitin natin pang differentiate dito. Take note, E is what? Constant. No? Constant yung ating source voltage. Sino lang variable natin? That is RL. So hindi ko na i-differentiate yan. Kayang-kaya mo na i-differentiate yan. That is only U over V. But this case, ito yung ating U, ito yung ating B. So after mong i-apply itong ating derivative formula na yan, ito ang makikita natin. After equating to 0, ibig sabihin at maximum power, yung ating load resistance, it should be only equal to internal resistance. So ibig sabihin, yan yung condition palagi na kailangan nating masatisfied to achieve maximum power so that the power at the load side, it will be maximum. So the power absorbed by our load resistance will become maximum if its given value it is equal to equivalent internal resistance of the whole circuit. So therefore, at maximum power, RL is equal to R. Ano gagawin natin? So itong condition na to, yan ngayon ang isa-substitute natin dito. Alright? After the substitution, Excuse me. Okay, after natin i-substitute, therefore, the maximum power, it is now equal to E squared over 4R. So, yan ay magiging equation. So, that is the maximum power that can be supplied to our load resistance. Pero ito lang tatandaan natin. This given idea, it is only derived using what? Simple series circuit. Okay? Simple series circuit. Ibig sabihin, yung equation na yan, pang series circuit na. Pagka hindi na siya series circuit, hindi mo pwedeng gamitin yung equation na yan. Nakuha ba? Unless you convert this given circuit into simple series circuit para magamit mo ulit yung equation na yan. Nakuha ba? So this equation, it is only applicable for series circuit. So maliwanag dito, your lead storage battery is rated so that is it. So ito yung battery natin. Gagamitin natin yan to supply a single load. So kung single load yan, i-connect lang natin sa terminal. So in that case, looking to the whole circuit, pero lang tayo series circuit. Kaya kung kabisado yung formula, kanina pa tapos yan. Therefore, the maximum power that can be supplied to our load, it should be equal. Source voltage is 12 is squared. I-divide mo 4 times the internal resistance of what? 0.01. Yan na yung ating maximum power. So that is the maximum power that the given load may achieve or may consume with respect to our source voltage of 12 volts. So ano lumabas kapatid? 12 squared divided lang by 4 times 0.01. So you have now 3,600 watts. Diba? So ano letter yan? This should be cut style. Okay, gets? So any question regarding problem number 14? So ito, hindi ko na derive, hindi ko na pinakita yung derivative. So ito yung gagamitin yung equation, and then after you differentiate, you just equate to 0. So ito yung makikita natin condition that RL is equal to R. Okay? So that is the condition to achieve maximum power. Nakuha ba? Any questions regarding problem number 14? May tanong ba tayo kay number 14, kapatid? Alright. So, one goes to number 14. Let us write number 15. No? A variable. Ano name ng formula, sir? So, this is the formula for maximum power. Formula, Pmax. Maximum power that can be delivered to our load resistor, or that is the maximum power that the given load may consume across a source voltage. Maximum power formula. Okay? So, yun ang tawag natin sa formula na yan. Formula for maximum power, but take note, this formula, it is only derived for series circuit. Ibig sabihin, magagamit mo lang to kung meron kang series circuit. Yes, for series circuit lang yan. Okay? Sir, paano po pagka hindi siya series circuit? Ito yon. Yes, pang series circuit lang yan. Sir, paano pag hindi siya series circuit? Kaparehas ng 15. Ito siya. A variable resistor R is connected in parallel with fixed resistor of 1.25 ohms. The combination is then connected across 12-volt battery with internal resistance of 0.25, solved for the maximum power that can be delivered to our load resistor R. So kunin natin yung equivalent circuit kay problem 15. So dito, clearly defined kung ano yung ating equivalent circuit, no? Kung paano connection ng ating circuit. Okay, so we have the variable resistor, that is our load, connected to fixed resistor in parallel. Then the combination, it is connected to our 12-volt battery with internal resistance. So, ito yung ating load resistance. So, this would be our RL. Connected in parallel with fixed resistor. Ano value nito? 1.25. Let us consider that is R1, which is connected across. So, pag across, okay, so we have the internal resistance of the battery, and you have the source voltage. So, based on problem, internal resistance of our battery, that is 0.25. Wait, wala. Voltage, that is 12 volts again. So, ano hinahanap? What is the maximum power? Okay, Pmax. So therefore, how to solve for that particular maximum power? So if you try to look, yung ating circuit, hindi na siya series circuit. So hindi natin magagamit itong equation na to. So paano natin ngayon makukuha yung maximum power na yan? So para hindi ka na lang ulit mag-differentiate, anong gagawin natin? Since we have already derived the formula for maximum power under series circuit, so the idea, let us simplify or let us reduce this given circuit into simple series circuit. Kasi pwede natin i-simplify any complicated network or circuit can be simplified into simple series circuit. So, anong gagamitin nating method? So, one of the corresponding methods in network analysis that uses to simplify any complicated circuit into simple series circuit, yung tinatawag natin using Thevenot's theorem or spelled as Thevenin's, no? So, si Thevenot's theorem, it is used to convert any complicated circuit into simple series circuit. So, kapag nakuha natin, ito magiging equivalent circuit natin. At that case, we have now only single load. Ito pa rin yung ating RL, which is now connected to our source battery. Yun nga lang, the given internal resistance, this should be your RTH. That is the Thevenot's equivalent resistance. And the voltage, that is your what? VTH. So lumalabas, after you convert this parallel into series circuit using Thevenot's theorem, ang source voltage mo na VTH, ang internal resistance mo na is RTH. So lumalabas at max power pa rin ang load resistance equal kay internal. Sino ngayon yung overall internal resistance ng circuit? It would serve as your what? RTH. Okay? So therefore, yung ating maximum power, ibabase natin doon sa ating initial formula for series circuit. Your E is the source voltage. After natin i-convert ito sa series, same source natin. That is the Thevenot's equivalent voltage. So meron ka ngayong VTH squared, i-divide mo kanino? 4 RTH. So this is now the general formula in solving maximum power. Ibig sabihin ng general, applicable na ito kahit anong klaseng circuit. Pero yung kanyang equation, binase natin sa series circuit. Kasi ang gagawin natin, any complicated circuit, we will convert them or we will simplify it into simple series circuit using Thevenot's theorem. So ang tanong na lang ngayon kapatid, paano ba kunin si RTH at si VTH? Yun ang kakailanganin natin. So step by step natin, just to recall, solving for RTH. Kunin ko yung original circuit, ano? Okay, so solving for RTH. So anong ginagawa? Dahil RTH yan, unang-una, i-open natin yung ating load. I-disconnect natin yung load. So tanggalin natin siya, i-open natin. So pagka-open mo, so basically hindi na siya connected, ano? So pwede nating tanggalin or sabihin natin dyan na lang. So after nating i-open yung ating load, disconnected, kapag meron tayong voltage source, lahat ng voltage source shorted, i-short natin. Kung meron kang current source, i-open. Voltage source shorted, current source open. So after nating ma-short lahat ng voltage source, i-open lahat ng current source, i-open natin yung ating load resistance. Tanggalin natin. So therefore, kung saan natin in-open, kumuha tayo ng ohmmeter. Mag-tap ka dyan ng ohmmeter. So kung ano man nasukat ng ating ohmmeter, it would be our RTH. Okay? So using this circuit, dahil shorted itong voltage source, naka-open ito, ano ngayon ang connection ng internal resistance at saka ni R1 with respect to this terminal? So obviously, these two resistance now are connected in one parallel. So that would be your RTH. So RTH now, that is the parallel connection of R internal resistance, which is 0.25, at saka yung fixed resistance na 1.25. Inverse. So this would be our RTH or the Thevenin's equivalent resistance that represent the overall internal resistance of the circuit. So ano lumabas ka ba dito? 0.25 inverse plus 1.25 inverse mo. So 5/24 ohms. Kuha? So pag may RTH ka na, next thing to do, kunin natin si VTH. So paano naman si VTH? Kunin ulit natin yung ating equivalent circuit. Okay, so solving for VTH, lahat ng source activated. I-on natin yung circuit. Okay? I-on natin. So ibalik natin lahat ng voltage source. Kung may current source, ibalik natin. Therefore, ano ulit ang gagawin? Basta kailangan yung load naka-open pa rin. Okay? So pag in-open natin yan, activated yung source, papalitan ko yung aking instrument. Instead na ohmmeter, connect ako voltmeter. So ang masusukat ng ating voltmeter, yung tinatawag nilang open circuit voltage, which is the VTH. Kaya open circuit voltage yan, that is the open circuit voltage at the load side. Kasi tinanggal natin yung load, so naka-open siya. Kaya kung ano yung marinig natin voltage dito, that is the open circuit voltage or that is the Thevenin's equivalent voltage. Okay? So let us try to look now for the given circuit. So since this is wire, tanggalin muna natin yung voltmeter para hindi kayo malikaw. So ibig sabihin, baliwala itong wire na to. So ito lang yung ating circuit. Ano ngayon ang connection nitong circuit na to? Tama ba? This is only what? Series circuit. Kasi baliwala na ito. So ito ating internal resistance, naka-series na kanila. R1. Okay? So therefore, pag kinuha natin yung voltage drop kay R1, ito yung voltage drop doon, maglagay tayo ngayon ng voltmeter dyan, that is your VTH. Try to observe or try to analyze sinong voltage ang sinukat ni voltmeter. Tama ba? For this given circuit, the VTH is the voltage drop across what? R1. Kaya for this circuit, your VTH, it would be equal to the voltage drop across what? R1. Eh, paano natin kukunin ng voltage drop across R1? So let's say the circulating current, that is simply I. So that is only equal by Ohm's law current I times R1. Ano si current? By Ohm's law, total voltage. Ilan ang voltage natin? 12. Ano connection ng ating circuit? They are now connected in series. Pagka series, additive. Ilan ito? 0.25 plus 1.25. So that is the total resistance. Total voltage over total resistance is the circulating current in the simple series circuit multiplied to our R1, which is 1.25. So kuha natin ngayon si BR1, which is for this given circuit equal yan kay VTH kasi doon nakatap yung ating voltmeter. Okay, so ano lumabas? 12 over 1.5 na lang times 1.25. So we have 10 volts, which is equal to VTH. So ibig sabihin, itong ating circuit na yan, pag sinimplify, therefore, from this given circuit, after natin i-simplify, pwede na lang natin sabihin, eto siya. Copy ko na lang ito. Okay? So, lumalabas ang source voltage natin, VTH, which is our source voltage, ilan ito? 10 volts. And the internal resistance, that is our RTH, which is equivalent kanino? 5 over 24. Kaya anong circuit na meron tayo? Series circuit. So therefore, tapos na ngayon yung ating problem. Maximum power now, ano source voltage? That is your VTH. Squared mo yun over 4. Ano internal resistance? RTH, which is 5 over 24. So we have now the maximum power delivered to our load resistance. Nakuha? Yes, very good. So the exact answer is 120 watts. That should be the answer. Nakuha ba, kapatid? Anong letter? 120. So dito sa ating choices, mayroon lang decimal point. So possible, ni-round off yung RTH, kaya hindi exacto. So sa atin, kinuha natin ng buo in terms of fraction, kaya full number yung nakuha natin sa sagot. But definitely, it is now equal kanina. Valid na. Nakuha ba? Nagets kung paano tayo gumamit ng Thevenins? So, una-una, kukunin mo si RTH. So, anong gagawin mo? Palagi, i-open mo lang yung ating resistance considered to be load. Kung meron kang voltage source, short mo. Kung meron kang current source, open. At saka ka mag-connect ng ohmmeter. Kung ano nasukat ng ohmmeter, it would serve as your RTH. And this RTH represent the internal resistance of the whole circuit. So after mong isolve si RTH, solve mo naman si VTH. I-open mo pa rin yung ating resistance, activated all the given sources. Then, kuha ng voltmeter. So kung ano nasukat ng voltmeter sa open circuit ng ating load, that would be your VTH. Nakuha ba? Any question regarding problem number 15? Nagets ba, kapatid? Kaya pagdating dyan, general formula for maximum power, VTH is squared over 4RTH. Applicable na ito kahit anong klaseng circuit. Pero before mo magamit, kailangan mo applyan ng Thevenins theorem para malaman mo ano yung source voltage, ano ang internal resistance. Pero kung simple series circuit lang, diretso kayo rito. Okay? Kung naka-series circuit lang, ito agad yung ating formula. Gets ba? Any more question regarding problem number 50? Okay tayo? So, iwanan ko, kapatid. Let us try number 16. So, for number 16, the Norton's equivalent of a circuit consists of 0.5 ampere current source in parallel with 4 ohm resistor. The Thevenins equivalent circuit is blank source in series with 4 ohm resistor. Ano ibig sabihin? So, if we can convert No? Kung kaya nating mag-convert ng kahit anong complicated circuit into series circuit using Thevenins, pwede rin naman nating i-convert any complicated circuit into parallel circuit. So kapag sinimplified natin yung isang complicated circuit into simple parallel, ano itsura? Pag sinabi nating parallel, any complicated circuit, pwede natin silang i-simplify into simple parallel. So, paano yung simple parallel na yun? So, meron lang tayong load resistance in parallel with the current source. Okay. So, ito naman, sabihin natin IN, and this RN, then this would be our load resistance. Right? So, kung meron tayong simple series circuit, meron tayong simple parallel circuit. So, kapag parallel, yung ating source is current source in parallel with its internal resistance RN. So, pwede natin i-convert itong circuit na to into parallel. So, ang gagamitin natin doon, converting any complicated circuit into parallel circuit. So, that is by means of what? Norton's theorem. Okay? So, converting it into parallel, ang gagamitin natin is Norton's theorem. So, ibig sabihin, kanina nakita na natin, any circuit, pwede rin natin i-convert into series circuit. So, from this parallel, pwede natin i-convert yan diretso into series. Or si series, pwede natin i-convert into parallel. So, kapag ka-series, sinong ginamit natin? That is actually our Norton's, diba? Or Thevenins rather. So, ibig sabihin, pwede nating pagpalit-palitin niya. Kung sawa ka na sa series circuit, pwede mo siyang gawing parallel circuit. Kung sawa ka na sa parallel circuit, pwede mong gawin siya series circuit. So, kapag series circuit, sinong gagamitin natin? Thevenins. Pag parallel, sinong gagamitin? Nortons. So, pwede natin i-convert si series to parallel or parallel to series. Sir, paano natin i-convert yun? So, in order to convert simple series circuit to parallel circuit or to convert Nortons to Thevenins, so gagamit lang tayo ng tinatawag na source transformation. So again, this would be your RTH, and this should be your VTH, and this should be still our RL. So kapag series circuit naman yan, it is under Thevenins, no? Or Thevenins. Right? So, pwede natin i-convert from parallel to series or series to parallel. So, paano natin i-convert yan from Nortons to Thevenins? So, using what? Using source transformation. Paano yung source transformation? I-convert natin si current source papunta sa voltage source or voltage source to current source. So, source transformation. So, kung gusto natin kunin si VTH, ibig sabihin, from current source, i-convert natin sa voltage source. So, by Ohm's law, it should be equal to the Norton's equivalent current multiplied kanina, Rn. And your RTH is equal to Rn. So, ibig sabihin, from parallel, convert natin sa series using source transformation. Now, pwede rin naman, from series to parallel, kaya kung gusto natin kunin si IN using Ohm's law, VTH over RTH. And your Rn, it is equal to RTH. Nakuha ba? So that is only using source transformation. So kung paano mo kinuha yung ating Rn o yung ating RTH, ganun din sinusolve si Rn. Ang pinagkaiba lang, paano solving yung ating In. So kapag kinuha naman natin si In, let's say, kanina, no? Using BTH, kung paano natin sinolve si RTH, ganun din yung way to solve for Rn. Ang pinagkaiba lang kay Norton's, pag sinolve natin si In, let's say, in this given circuit, no? Ay, ito pala yung ano. So let's say, ginamitan natin ito ng Norton's. So paano kukunin si In? I-recall lang natin si Norton's. No? So, for example lang, ito yung ating complicated circuit. Gusto natin itong i-simplify into simple parallel using Norton's. So, kung paano i-solve si RTH, ganun din ito. Kaya nga, they are always equal. Okay? Kung paano kinukuha si RTH, ganun din si Rn. Ang pinagkaiba lang, In. Kaya nga yung iba, ang tawag nila kay Norton's current, that is also the short circuit current, ISC. Bakit siya short circuit? So, i-activate natin lahat ng source. Anong gagawin natin? Instead na i-open mo yung load, i-short natin. So, pag sinort natin, palitan ko siya as wire. So, ibig sabihin, kapag naka-short yan, wala nang current na dadaan dito. Ito na lang yung current. Ito ngayon, sino? Si IN. So, since shorted yan, tama ba? Wala na rin current na dadaan dito. Shorted na yan. So, pagdaan, pag-supply ng ating current here, so whatever the source voltage, i-divide mo na lang kay R. Tama? That is your IN. Kasi pagka sinort na natin ito, wala nang current dyan. Kasi gusto ng current, minimum yung opposition, minimum yung resistance. Eh di ba, pagka short circuit, ano equivalent resistance? Approximately 0. Kaya pag kinuha natin yung ating IN dyan, i-short mo yung terminal ng ating load. So, nung sinort ko yung ating load, pati ito shorted kasi parallel yan. Kaya in that case, your I sub n, check natin ano. Ano yung volt? It should be what? 12. Ano yung internal resistance ng battery, given battery, dito kay number 15, no? That is 0.25. Ano yung lumabas na short circuit current? 48 ampere. Now, i-check natin using the source transformation. Di ba kanina, kinuha natin ng BTH ito? Anong naging BTH natin? Your BTH is what? 10. Tama? Anong RTH? 5/4. So therefore, using the source transformation, yung IN na na-compute natin using the original circuit, kunin natin, let us verify using your series circuit. Kumbaga, nakuha natin ito, gagawin ko siyang Norton's. So si IN na lang kukunin ko using source transformation. Ano yung BTH na na-compute natin kanina? 10. Ano yung RTH na na-compute natin? Di ba 5/24? So dapat yan equal din kay 48 ampere para alam natin na tama yung nakuha natin IN. Equal mo, so you have also 48. Nakuha ba? So yun lang ang pinagkaiba ng Norton's at saka Thevenin's. Instead na i-open mo yung ating load kay Norton, sino-short. Tapos kukunin mo yung current na dadaan dun sa short circuit. Kaya sa ibang book, instead of Norton's current, ang ginagamit is short circuit current. Nakuha? Pero kung meron ka ng BTH, para hindi ka na lang ulit mag-solve ng Norton's, ang gagawin mo, gamitin mo na lang ng source transformation. That your IN is VTH over RTH and your RTH is equal to RN. So same also, kung meron ka ng Norton's at hinahanap yung equivalent Thevenin's, huwag ka na ulit bumalik sa Thevenin's theorem. Gamitan mo na lang ng source transformation. Your VTH, it should be equal to IN times RN and your RTH is equal to RN. Nakuha ba, kapatid? So at this case, for problem 16, binigay that the Norton's equivalent current, it is equivalent kanino? 0.5 ampere. At ano yung kanyang Norton's equivalent resistance? 4 ohms. Ano hinahanap? VTH. Therefore, using source transformation, your VTH, it should be equal kanino? IN, which is 0.5 times kanino? 4. So, ilan ito? 2 volts. Ano ngayon si RTH? So, si RTH, it should be also what? 4 ohm. So, ito na hinahanap ng ating problem. So, itong illustration ko, just to check kung paano ba kinukuha ng diretso si IN of any complicated circuit. So, for problem 16, ito hinahanap. You have 2 volts in series with 4 ohm resistance. That is the equivalent Thevenins of our Norton equivalent circuit. Anong letter yan, kapatid? So, 2 volts in series with 4 ohm, anong letter? Arriba. Nagets ba? Any question regarding Norton's and Thevenins theorem? Si Norton's, convert any complicated circuit into simple parallel. Si Thevenins, convert any complicated circuit into simple series circuit. Alright po ba? Any question regarding problem number 16? Gets natin yon mga kapatid? Gets natin? Nakuha ba?
Yes,
Okay
sir.
tayo? Nakasunod? Yan kay Thevenins. Kay Thevenins at saka Nortons. Okay. So, iwanan ko si Nortons at Thevenins. So, let us try number 17. So, for 17, we have 3 resistors, 10, 20, and 30, connected in delta. Determine their equivalent resistance in Y. No? So, another methods in order to simplify network that is converting 3 resistances connected in delta into Y or Y into delta. So siguro, isa sa pwede nating i-recall, sir, paano ba natin malalaman if 3 resistance or 3 loads are connected in delta or connected in Y? So simple lang, no? 3 loads or 3 resistances are connected in delta if they form a single loop. Kapag nag-form sila ng single loop, meron tayong delta. Why yan? 3 resistances are connected in Y if they have one common point of connection. Okay? So, balikan natin yung ating delta to Y. Okay ba? Start to delta. So, alam natin, take note, delta yan, usually, ang symbol ng delta is triangle. Kaya nga, pwede natin sabihin, 3 resistances are connected in delta if they will form a single loop. So, para hindi tayo maligaw, lagyan natin to ng terminal. This is A, this is B, this is C. Walang problema kung saan din si A, B, C. So therefore, maglagay tayo ng resistances in between terminal. So ito ngayon, yung mga resistance connected in delta. So the resistance here, usually, ang symbol na ginagamit, double subscript. Kung saan siya connected between terminal to its resistance. So RAB, that is in delta. So ito, between B and C, so this is RBC. So this is now RCA. So that will be our 3 resistance connected in delta. So kahit hindi siya naka-triangle, kapatid, okay? Kahit hindi siya naka-triangle, alam mo na delta yan kapag 3 resistances are connected to form a single loop. Basta meron kang single loop between these 3 resistance, connected sila in delta. Not necessary na kailangan makita mong triangle, no? Hindi siya gano'n. So, nire-represent lang natin na delta na naka-triangle para madaling identify. Pero, pag nakita ng tatlong resistance and form a single loop, they are connected in delta. Now, paano si Y? 3 resistances are connected in Y if they have one common point of connection. So, para madali natin ma-convert from Y to delta, ilalagay ko sa gitna yung kanilang equivalent delta or equivalent Y. So, alam natin, Y yan, if 3 resistances are connected to one common point. Ito ngayon, yung ating resistance kay Y. Ano label? Kung saan nakatapat na terminal, ito si RA. Ito ngayon, RB. Ito, RC. Pag single subscript, no, single subscript lang, single letter, that is Y. Pagka double subscript, usually delta. Pero meron tayong double subscript. Ano yung double subscript na isa? Pag ito is N. Yung N na yon, ibig sabihin, the common point or the neutral. Okay? Kaya most of the time, hindi na nilalagyan ng N. Kasi yung N, ito yon, yung neutral point. Yung common point. Okay? So, yun siya. Kaya most of the time, hindi na sila sama si N. RA, RB, RC na lang. Pero minsan, lalagyan nila ng N. Ibig sabihin, connected between A to neutral, B to neutral, C to neutral. Okay? So, pagka 3 resistance connected at one common point, Y yun. 3 resistance connected so as to form a single loop, so that is what delta. So here, binanggit ng problem is 3 resistances are connected in delta. So let us consider, RAB walang problema, ito si 10. RBC, let's say this is 20. And RCA, this is what? 30. So hinahanap natin si RA, RB, and RC. So how to solve for RA, RB, and RC? So anong gagawin natin? So solving Y for delta to Y, recall lang natin, ano? Given is delta, we want to convert it into its equivalent Y. So ako, ang ginagawa ko dyan, scissor method. So paano yung scissor method? Di ba pagka gumamit ka ng scissor, tignan mo siya, no? Pagka inopen mo yung scissor, anong makikita mong symbol sa scissor? Di ba? Pag binuksan mo yung scissor, anong symbol yon? Di ba? X. So X represent what? Multiplication. Di ba? So pag scissor, dalawang line yun, 2 lines that crosses. So symbol siya X. So represent multiplication. So ibig sabihin, given si delta, kukunin mo si Y, scissor method ka. Ibig sabihin, maglagay ako ng scissor. Let's say, maglagay ka ng scissor kay A. No? Guguntingin ko si A. Kung saan nakatapat yung dalawang blade ng ating scissor, yung multiply. So, scissor ako kay A. Maglalagay ako ng scissor dito, saan nakatapat yung blade. Ito ngayon yung blade ng scissor. So, you just multiply. So, lalabas, RA, it is just simply equal kanino. The product of its adjacent side, RAB, multiplied kanino, RCA. Then, sa baba, anong kukunin mo lang? So, that is simply RAB plus RBC plus RCA. Everything will follow. So, from delta to Y, denominator mo constant. Ang magbabago lang yung ating numerator. Ito lang magbabago. Palagi ang denominator, summation ng ating delta. So, yung numerator, apply ka lang palagi ng scissor. O, gusto kong kunin si B. Scissor method na rito. Sino nasa gilid ng scissor? RAB, RBC. I-multiply, divide this by it. Meron ka ng RB. Gusto kong kunin si RC, multiply yung nasa adjacent over yung constant. Kuha? So, ganun na siya palagi. Okay, so no more problem. Pwede na natin i-solve. Solving for RA. So, in this case, sino nasa gilid niya? That is what? 10 and 30. So, 10 times 30, you have 300 over summation ng tatlo. So, 10 plus 20 plus 30. So, meron tayong 300 over ilan ito? 60. So, this is what? 5 ohms. Okay? Next, RB. Sino nasa gilid ni B? That is 10 at saka 20. I-divide natin 60 ulit. So, this should be 200 over 60. 20 over 6. So, you have 3.33 ohms. Lastly, RC. Sino nasa gilid ni RC? 20 times 30. I-divide lang natin kay 60. So, this is 600 over 60. So, that is what? 10 ohms. So, yan ang hinahanap ng ating question. So, walang problema, no? Hindi kailangan ng proper sequence. Okay? Wala naman kasi binanggit kung sino may RAB, RBC, at RCA. Basta alam natin, those three are connected in delta. So, hindi importance pagdating dyan kung sino yung mga una, sino yung pangalawa, sino yung pangatlo. Basta importante, dapat ito yung magkakasamang resistance in Y. So, anong letter yan? So, obviously, they should be at what? Arriba. Nakuha ba? So, that is from delta to Y. Eh, sir, paano pagka binaliktad? So, pagka Y to delta naman, from Y, i-convert natin sa delta. So, hinahanap natin yung double subscript. Let's say, hinanap ko si RA. So, ganun ulit. You just multiply two adjacent side of your Y. Kada dalawang magkadikit na side na naka-Y, i-multiply. So, multiply mo RA times RB. Right? Tapos, RB, sinong kadikit? RC. Tapos, si RC, sino pang kadikit? RE. Then, you just add. Yun ang numerator mo. Ang denominator, anong letter ang nawawala? RAB. So, sino letter? C. So, that would be your divisor. Or simply, sino yung ka-opposite niya? Sino yung ka-opposite niya? Katapatan. Sa ating network, ang katapatan ng RAB, sino? RC. So, gusto kong kunin si RBC, sinong ka-opposite niya? Si RA. Ito denominator. Gusto kong kunin ito, sinong ka-opposite niya? RB. So, ibig sabihin, from Y to delta, ang numerator, ito naman, constant. Ang magbabago, yung denominator. So, ang denominator mo, that is the opposite of the resistance in delta na kinukuha mo. Nakuha ba? So, if you want to check, so RAB, let's say, sino ka-opposite ni RAB diyan? sino? Si RC. Nakuha natin RC, that is then. So, kapag kinuha natin ang numerator, RA times RB, RB times RC, then RC times RA, i-add mo lahat yun, i-divide natin kanino. Kay 10, makakuha natin si RAB. So, tignan natin. So, let's say you have 5 times 20 over 3 para eksakto, plus 20 over 3 times 10, then plus you have 5 times 10. Yan ang numerator natin. Divide. So kung kukunin ko si RAB, sino opposite niya? RC. Ano yung nakuha natin RC? 10. Uy, ba't naging 15 tayo kapatid? RA, 5 times 3 kasi 6 ito. So na. Asus. But 3 kasi 20 over 6, hindi 3. Yeah. Plus, you have 10 times 20 over 6. Oh, 9 pa. So, plus 5 times 10 over 10. But 6 ang na-input. But 3. So, 10 na. Okay? Sabi C. So, 20 over 6. Nalagay ko na 3 kasi napakaraming 3 dito ako. Kaya akala ko 3. So, 20 over 3 CRB. So, this is RA times RB. This is RB times RC. So, sa taas, this is RA, this is RB. Then, this is RC, RB. And this is RA, RC. So, sa baba, divide by RC. You have RAB, which is also 10. Sakto lang, 10. Okay? So, that is only converting Y to delta or delta transformation. So, usually, dinadraw lang natin si delta in terms of triangle Y para mas mabilis or mas mabilis yung ating conversion. Okay? Nakuha ba? Any question regarding problem number 17? Delta to Y or Y to delta. So, that is another method to simplify a corresponding network. Okay? So, any question regarding 17? So, one ko yung conversion na yan. Let us try number 18. Objective lang. Ano bang unit? No? Ibig sabihin ng problem, ano bang unit ang ginagamit natin to measure the capacity of our battery? Diba, pag bumili tayo ng mga gadgets ngayon, kasi alam natin na main source nun is battery, ano yung una natin tinitingnan? Anong rating ba ng battery? No? At titingnan natin that represent its corresponding charge. So anong unit yon? So kapag cellphone, siyempre maliliit lang yan. Anong tinitingnan natin? Isa sa important rating ng cellphone sa tinitingnan in terms of gaano mo siya katagal, gaano siya reliable gamitin. Anong tinitingnan mo doon? Anong capacity niya? Milliampere. Di ba? So habang tumataas yung kanyang milliampere hour, ibig sabihin, matagal bago siya malopat. Matagal bago siya ma-fully discharge. So ibig sabihin, yung storage battery, it represent the capacity in terms of charge. And the charge of the battery usually measured in terms of what? Ampere hour. Pagka medyo malaki. Mga battery ng sasakyan, usually ampere hour yan. Pero kung mga electronic gadgets, usually they are measured in terms of what? Milliampere hour. And that is the same as the product of current at saka sino. Fine. So ano letter? This should be dog style. So that is the unit used to represent the charge capacity of the given battery. One ko kapatid. Number 19. For number 19, a total of 0.8 kilogram of water. I think this is not 200, ano? This is only 20. Hindi lang nabasa no ating PowerPoint yung degree symbol. Okay? Kasi wala tayong tubig at 200. Kasi pag 200 degree na yan, sigurado steam na yan. Ano? Hindi na siya tubig, gas na siya. So this should be at 20. Kasi alam natin, boiling point of water is only 100. Kaya malabo na magkaroon tayo ng tubig at 200. So I think this should be 20. Okay? So it is placed in a 1 kilowatt electric kettle. How long the time in minute is needed to raise the temperature of water to, so I think this is 100 degrees Celsius. So let's say gusto natin magkape. So papailan tubig using electric kettle. So let us consider ito yung ating electric kettle. So let us consider, no? We have electric kettle. So nilagyan natin ng tubig yan. So the total mass of water inside the electric kettle, let's say this is H2O. So the mass of our water inside the electric kettle, that is 0.8 kilogram. And let us consider its initial temperature, that is only at 20 degrees Celsius. So gusto natin magkape. So pinainitan natin yan, pinakuluan. So we try to increase the temperature of this water, no? Ininit natin yung tubig until kumulo. So alam natin, boiling point of water is at 100 degrees Celsius. So let us consider, in order to increase the temperature of this water from 20 to 100, gumamit tayo ng electric kettle, wherein the rated power ng ating electric kettle is 1 kilowatt. So hinahanap ngayon ng problem, gaano katagal? How long would it take? Now, let us consider capital T na lang. So, T represent the time. So, kunin na lang natin in terms of minutes. So, ibig sabihin, gaano ba tayo katagal or gaano ba katagal bago kumulo yung tubig dito sa ating electric kettle if the rated power of our electric kettle is 1 kilowatts. So, here, walang binanggit kung ano efficiency ng ating electric kettle. Therefore, let us just consider efficiency of our electric kettle that is simply what? 100%. Ibig sabihin, yung energy loss is what? Negligible. So ano nga ba ang efficiency? Diba pag sinabi natin efficiency, that is the output power over kanino? Input power. So now, kapag in-apply natin yan dyan sa ating electric kettle, so i-multiply na lang natin in terms of time. T over T. So anong lumalabas? In terms of energy, output power multiplied time. So that is the output of our electric kettle. So di ba, power multiplied time is energy. Anong klaseng energy ba ang output ng electric kettle? Anong ginawa ni electric kettle? Pakuluan yung ating tubig. So ibig sabihin, that is in the form of what? Heat. Heat energy yung kanyang output that causes the increase in the temperature of water. Now, ano input ng ating electric kettle? So of course, para magawa ni electric kettle na increase yung temperature ng ating tubig, kailangan i-plug in muna natin siya. So therefore, the input to our electric kettle in terms of energy is what? Electrical energy. Ano electrical energy? That is the power multiplied by time. Ano yung input power? That is the rated power of your electric kettle multiplied kanina pa. So this should be equal to P times T. Now, ano ba yung ating heat energy? Q. Ano heat energy? From your chemistry or thermodynamics or physics, ano formula ng heat energy? Si Q. Naalala, kapatid? Ano formula ng ating heat energy? Anong formula niyan?
So, MC
Sige.
delta T.
Yes, tama. No, that is the sensible heat. MC delta T. Now, that is the energy or that's the heat energy required to raise or to change the temperature of any substance. So this is equal to MC delta T. Delta T is the change in temperature. Your C is the specific heat. This is constant. Ano is specific heat for water? So for water, that is 4.186. Anong unit? This should be in terms of what? Kilojoule per kilogram degrees Celsius. But take note, this is specific heat. It is only for water. Yung iba, ang gamit, instead of 4.186, that is 1 kilocalorie per kilogram degrees Celsius. Kasi alam natin, 1 kilocalorie is how many kilojoule? 4.186. Nakuha ba? But this value, it is only for what? Water. Kasi si specific heat, constant yan, depending kung anong substance ang pinag-uusapan. Okay? So you have MC delta T, you have now the input power over rated power multiplied T. Okay? So wala nang problema. Since walang binigay na efficiency, let us consider 100% or losses is negligible. Kaya solving for your time, it would be only equal to MC delta T, i-divide natin kan rated power. Ilagay ko ang unit para makita natin anong unit ang lalabas. Ano? This is 0.8 kilogram, specific heat, 4.186 unit kilojoule per kilogram degrees Celsius. Change in temperature, so change in temperature is final minus initial. 100 minus 20, so that is 80 na lang. No? divide, rated power? 1 kilowatts. Ano yung rate ng kilowatts? Diba, ang kilowatts is kilojoule per second. Tama? So therefore, matitirang unit? So pwede kong i-cancel yung kilogram and kilogram. Pwede kong i-cancel degree Celsius, degree Celsius. Pwede kong i-cancel yung kilojoule kay kilojoule. So tataas ngayon yung unit na seconds. Anong hinahanap? In minutes. So dito pa lang, i-convert na natin. Alam nyo natin that there are 60 seconds per minute. Okay, so cancelled na yung seconds. The answer is already in minutes. Pwede na diretso. Okay, so 0.8 times 4.186 times 80, i-divide ko na lang na 60. Yun ang sagot. So it would take only for about, gano'ng katagal? The time it takes bago kumulo yan, it would take only 4.46 minutes. That should be our answer. Meron ba? 4.46. Ayun. Anong letter? This is Ariba. Nakuha? Gets ba? Any question regarding problem number 19? Nakuha? Any question regarding that? So, meron lang tayo, direct substitution. So, pagka hindi binanggit kung ano efficiency niyan, let us consider that is what? 100%. So, kung electric kettle, automatic, its output is what? Heat energy. That is sensible. Since ang ginawa lang ni electric kettle is to increase the temperature of the water inside it. Okay? So, may tanong kay number 19? Kuha natin. Number 20, ano sagot kapatid sa tingin niyo? How many calories does electric heater of 100 watts generate per second? Ano sagot kapatid? Sige nga. How many calories does electric heater of 100 watts generate per second? Ano sagot kapatid? So, di ba, the rated power, 100 watts. Di ba? 100 watts, it is just 100 joule per second. But for every 1 calorie, how many joule? 4.186. So, ibig sabihin, no problem, pinapa-convert lang si 100 watts into calorie per second. Yun lang din siya, no? Conversion na. So, therefore, kunin natin yung sagot. So, cancel natin yung joule. So, ano natira? Calorie per second. Ibig sabihin, 100 watts is also equivalent to how many? 100 divided by 4.186. That is 23.89 calories per second. Ibig sabihin yan, kung yan yung ating electric kettle, so every seconds, kaya magbigay ni electric kettle ng 23.89 calorie of heat or kaya niyang increase yung heat energy ng ating water by 23.89 per seconds if the rated power of our electric heater is 100 watts. Nakuha ba, kapatid? Any question regarding problem number 20? So that is just conversion from watts into calorie per second. Anong letter ito, kapatid? Ayun, baliktaran. My favorite. Kuha? Yes, baliktaran. Na, kuha, kapatid? Any question regarding problem number 20? Iwanan ko, kapatid. So let us try number 21. So objective. While comparing magnetic circuits and electric circuits, so familiar tayo sa magnetic circuits. So any given machines, no? So machines or equipment that having a core, no, basta ang principle is under electromagnetic induction, so definitely palagi magkasama yung ating electric circuits at saka magnetic circuits. Yun nga lang, most of the time, medyo hindi tayo nakakapag-focus kay magnetic circuits. Palagi, nakapokus tayo kay electric circuits. So therefore, para hindi natin makalimutan yung mga parameters dyan sa ating electric circuits, kunin natin ang relation ng electric circuits at saka magnetic circuits. So counterpart ng ating magnetic circuits pagdating kay electric circuits. So kunin natin, ano? So in terms of electric circuits, then kunin natin yung kanyang counterpart pagdating sa magnetic circuit. So its counterpart pagdating dyan sa ating magnetic circuit. So usually, yung simple representation ng ating relation between electric circuit and magnetic circuit, dito sa ating course. Sabihin natin, pinakamadali dun sa analysis ng ating transformer. Okay, so let us consider this will be the core of our transformer. So, lagyan natin ng ating magnetic wire. Okay. So, just to recall, no, ano relation ng ating electric circuits at magnetic circuits. So, in order to have a flow of electron here, so supplyan natin na ng EMF. For electric circuit, we have the source that is your EMF or electromotive force, which is usually measured in terms of what? Volts. Kapag may voltage na tayo dyan, so definitely, we have now the flow of electron that is characterized by our current. So, meron tayo I dyan, that is the current, measured in ampere. O sabihin na lang natin that is current. Symbol is I. So, alam naman natin yung unit ng EMF, symbol na lang gamitin ko nito. Symbol is E. So, alam natin, for every action, meron tayong opposition, resistance. So, that would be our R. Okay? So, sinuplayan natin ang voltage dyan. Therefore, you have flow of current. So, as the current flow to the given magnetic wire, so therefore, the given coil will be energized. And the energy, therefore, this coil will be energized. So, it will give its corresponding force. O yung tinatawag natin magnetic line of force. So, in order for this magnetic line of force, so kailangan yung ating coil makapag-develop ng tinatawag nating MMF. Sino yung ating MMF? MMF, that is the magneto-motive force. So, ibig sabihin, that is external force that will cause the flow of magnetization. Kaya tinawag natin siyang magneto-motive force. Ito is electromotive force. External force applied to your circuit that causes the motion of electron, which is characterized by our what? Current. So once the given coil is energized, so meron tayo MMF, the equivalent magneto-motive force or the external force that causes the movement of our magnetic line of force, which is characterized by our what? Flux. Ang symbol that is P, wherein the flux produced, it will move from primary to secondary. You have the flux. You have the flux that rotates from primary to secondary. Kaya nga, due to the movement of our magnetic line of force from primary to secondary, you have again the changes of flux within this coil. So you have the voltage at the secondary. So that is the idea of electromagnetic induction. So therefore, alam natin, for every applied force, meron tayong opposition. So the opposition offered by our core, no, kung saan natin inilatag itong mga wire na yan, tawag natin is core. So magbibigay yan ng opposition to the magnetism. Ang tawag natin is sino? Reluctance. Ang symbol, yung malantik na R. So that is the reluctance. So reluctance represent the opposition to the flow of magnetic line of force o yung ating flux that is provided due to what? MMF, or that is the magneto-motive force. So ibig sabihin, kapatid, if you try to compare no, electric and magnetic circuits, so pwede nating sabihin the counterpart of EMF o kapartner niya o yung kanyang katandem pagdating kay magnetic circuits. So EMF represents sino? MMF. And the current represents sino? Flux. And the opposition resistance represents sino? Reluctance. Kaya tandaan mo lang kung sinong ka-counterpart ng magnetic circuits sa electric circuits, hindi na tayo maliligaw in analyzing magnetic circuits. Kasi still, circuits pa rin yan. Kaya kung ano Ohm's law sa electric circuits, yun din ang Ohm's law pagdating kay magnetic circuits. So ano ibig sabihin? Kung gusto natin kunin yung ating voltage, di ba by Ohm's law, current times kanino? Resistance. So therefore, pag gusto natin kunin si MMF, apply Ohm's law. Sino ang counterpart ng ating current? Si flux. So therefore, MMF, that is simply flux times the reluctance. So on and so forth. Okay, so tanda mo lang, sino counterpart ng electric circuits sa magnetic circuits, then you just apply Ohm's law, hindi na tayo maliligaw pagdating sa number 21, hinahanap lang sino yung counterpart and electric circuits is compared with which parameter of the electric circuits. So hinahanap lang natin sino ang counterpart ng flux pagdating saan? Electric circuit. So kita na natin that is only the corresponding current. Yun lang hinahanap sa problem number 21. So anong letter ito kapatid? So this should be baliktaran. 22. Magnetic line of force. It is also known as what? Sino yung magnetic line of force? The magnetic line of force, that is only the other term used for flux. Kaya nga itong flux na to, usually measured in terms of lines. So lines, that is in English system. Kaya meron tayong unit of flux can be measured in terms of what? Lines. Kasi si flux represent the magnetic line of force. Now, kung babalikan natin, the unit of flux lines, it is also equivalent to a unit of what? Maxwell. So, ibig sabihin, the number of lines equal to the number of Maxwell. Kaya si lines, pwede natin sabihin, that is also a unit of flux in terms of what? CGS system. So, this flux, also known as the magnetic line of force. So, anong letter yan? This should be baligtaran. Number 23, objective. Ano si permeance? Ano si permeance? No? Permeance is analogous to. So, ibig sabihin ulit, comparing electric circuits to magnetic circuits. So, permeance is under magnetic circuits. So, sino hinahanap natin? Sino counterpart ng permeance sa electric circuits? Okay, define natin, ano ba si permeance? Permeance, ang symbol, capital P. P rin talaga ang ginagamit. So, hindi ko pwede baguhin. So, permeance. So, let us consider capital P here or capital P here is permeance. Okay, pag kinuha natin si permeance, siguro, gawin na lang natin yung malantik na P or P talaga permeance. Pag kinuha natin si permeance, ano ba definition ng permeance? Permeance, that is the measure of the ability of any given material that attracts magnetism. That attract magnetism. Kumbaga, it allows the magnetization of this given material. So kapag kinuha natin si permeance, capital P, permeance, no? So that is in formula, it is the reciprocal of what? Reluctance. No? Permeance is the reciprocal of reluctance based on its definition. Kasi si reluctance is the measure of the ability of any given material that opposes magnetism. Si permeance naman, attract or allow magnetism. So based on their given definition, you may always consider permeance is the reciprocal of what? Reluctance. So doon ngayon tayo mag-start. Alam natin kapatid, the counterpart of reluctance is sino? Si resistance. Kaya kapag kinuha natin 1/R, sino ito kapatid? Reciprocal of resistance sa electric circuits, it is known to be what? Anong tawag natin sa reciprocal of resistance sa electric circuits? Sino siya? Anong tawag natin? Reciprocal of resistance sa electric circuits.
Conductance, sir.
Conductance.
Yes. Conductance, capital G. So therefore, by inspection, reluctance is the counterpart of resistance, which is reluctance is the opposite of what? Permeance. Therefore, conductance is the opposite of resistance. So in that case, ito palang permeance na to, it is referring to what? Conductance sa electric circuit. So yun ang hinahanap ng ating problem number 20. So anong letter yan? Ayun, that is aming pa. So, any question regarding problem number 23? Gets ba kapatid? Any question? Pwede natin sabihin, permeance is reciprocal of reluctance since, based on their definition, permeance allow magnetism, attract magnetism. So, si reluctance opposes. Kaya, in terms of that, they are opposite to each other. Okay, naku ba? Any question regarding problem number 23? Okay ka? So, any questions? So, before tayo mag-break, the second, yung pangalawang break natin. So, before natin ituloy-tuloy hanggang 7 o'clock. Hanggang 7 o'clock tayo ngayong Saturday. But take note until starting next week, Friday na yung ating klase. No? Friday na, 9 to 12, 1 to 4 every Friday na. Ngayon lang kasi nag-make up tayo kahapon kasi is holiday. Alright? So, may tanong ba before tayo para yung gusto mag-early dinner or mag-merienda ulit para dire-diretso hanggang 7 o'clock tayo malipasan ng gusto. May tanong ba kapatid? Any questions? Okay na tayo kapatid? Okay, so merienda muna tayo ulit. 15 minutes para mapahinga lang yung ating mata for 15 minutes. So after that, question tayo. Okay? Question tayo after 15 minutes. Ano ba ako? Okay, so let us try number 24. So for number 24, a magnetic coil produces a 100,000 Maxwells with 2,000 turns and with a current of 2.0 amperes, just simply 2 ampere. The current is cut off and the flux collapses in 0.01 second. What is the average voltage that will appear across the given coil? So let us just consider, kapatid, we have a coil. So yun natin yung ating equivalent circuit. So focus na lang tayo doon sa ating coil. Okay, so let us consider, no, we have a given coil that is connected across a DC source. So, sabihin na lang natin yung E. So, let us consider, no, we have a switch. So, in terms of this given arrow. So, initially, matagal lang connected yung ating coil in this given source battery. So, based sa problem, so before natin i-open yung ating switch, so we have the corresponding current here. So sabihin na lang natin, this would be our I. So the current in the given circuit based sa problem that is 2 ampere. So at this given current, so the flux or the given coil is energized. So therefore, it provides the necessary magnetic line of force or our flux that is equivalent to 100,000 Maxwell. So therefore, let us consider in-open natin yung switch. So this is switch, so open. So yung arrow natin palabas. So therefore, pagka-open natin dyan, so hindi na connected yung ating coil to the source voltage. So anong binanggit, no? The current is cut off and the flux collapses in 0.01 seconds. So ano ibig sabihin, no? Ibig sabihin, at time equal to 0 or that is at the time na i-open pa lang natin yung ating switch. So observe natin yun, at time equal to 0, ibig sabihin, may open pa lang natin yung ating switch. So the time elapsed is still 0. So the current here, no, yung open pa lang natin at the instant na yung open natin itong switch. So the current in the given circuit is still 2 ampere. Sabihin na lang natin that is I sub 1 or the current when the circuit is still closed. So the flux provided, it is what? 100,000 Maxwell. So anong ginawa kapatid? So inopen natin, then sabihin natin kapatid, after may total time elapsed. Simula nung i-open natin yung ating switch, palipas tayo ng 0.01 second. Anong nakita natin? So since the given coil, it is no longer connected to our source voltage, so definitely, pag naka-open na yung switch, the equivalent resistance of open circuit is what? Approaching to infinity. So pag mataas na yung resistance, ano na magiging current? So 0. Kaya ano nangyari? Binanggit ng problem, current is cut off. So at this case, I sub 2, that is only the current in this given circuit. When the time elapsed, simula nung i-open yung ating switch, it is 0.01, collapses. 0. So since wala na tayong current that would energize the given coil to provide its given flux, so therefore, the corresponding flux also becomes 0. So ano hinahanap ng problem? Alam natin, this coil represent inductance. So hinahanap ng problem, what is the average voltage that will appear across the coil? Or simply, what is now the voltage across the coil? Voltage across the coil, pwede sabihin, that is the voltage drop across the inductance. So kung babalikan natin, solving for the voltage drop across inductance, it is always equal to L di over dt. So you have L di over dt, wherein di over dt, that is the change in the corresponding current per given time. So makakuha natin yung change of current since meron tayong final minus initial over the given time, so final over initial. So you have the change in current, di over dt. Ang problema, wala tayong value ng inductance. So paano ba natin kukunin yung ating inductance? Kung babalikan natin yung idea ni Michael Faraday, whenever there's changes or cutting of flux within a coil, voltage is induced. At alam natin, the voltage induced in the coil, it represents also the voltage drop across the inductor. Wherein, it is always equal to E, induced voltage in the coil, that is statically induced voltage, naalala, you have what? N dP over dt. Wherein N is the number of turns, given ba yung turns, okay? So based sa problem, the number of turns of our coil, that is simply equal to 2,000 turns. Now, dP over dt, that is the change in the corresponding flux per given time. So change, so pwede natin gamitin is the absolute value. Kasi change lang naman ang pinag-uusapan. But change in the given flux per given time. So either using LDI over dt to solve for the voltage across the coil, or you may use the idea given by Michael Faraday that whenever there's changes or cutting of flux within a coil, voltage is induced. Nagkaroon ng change of flux because of the change in the given current. Okay? Nakuha ba? Kaya if you want to determine kung ano inductance natin, so pag pinag-equate natin yan, you may use this equation to solve for the inductance. Now, pag kinuha natin yung inductance dyan, equate natin LDI over dt, which is equal to N dp over dt. So therefore, pwede natin i-cancel ngayon itong dt. So under differential equation, kung gusto kong kunin yung current, so pwede natin siyang i-integrate. So pag i-integrate natin yan, so if the current is 0, wala tayong mag-energize sa ating field o sa ating coil, so the flux, it is also what? 0. If the current is equal to I, therefore the flux is equal to P. So pag in-integrate natin yan, pwede natin gamitin Lino. Sino si Lino? So pwede natin sabihin that the inductance of the coil multiplied to the current passing through the coil, it should be equal to the number of turns times the flux produced by this given current I. Kaya makikita natin, kapatid, that talaga naman that the flux is the counterpart of current, or flux is proportional to your current. Kasi the inductance of the coil and the number of turns of the coil are always constant. Kaya nga alam natin, flux, it is always proportional kanino? Current. Sinong current yon? The current that would energize the given coil. So here, alam natin, if the current is 2 ampere, the flux is 100,000. And you have the number of turns, makukuha mo si L. So pag nakuha mo si L, pwede mo nang gamitin si DI over dt to solve for the induced voltage here. But since, para hindi na lang tayo mag-compute ng inductance, alam na rin natin, according to Michael Faraday, the voltage induced in the coil, it is always equal to what? N dp over dt. Isa na lang, kailangan alam natin that the given flux, it should be converted into Weber so that the voltage should be measured in terms of what? Volts. At alam na natin yung conversion from Maxwell to Weber. So pwede na lang natin gamitin itong equation na to. So pinakita lang natin kung paano solving yung self-inductance ng coil na para in case ma-encounter natin how to solve for the inductance of the coil, alam na natin kung anong formula. Sino yon? Lino. So pwede mo gamitin si Lino to solve for the inductance of the coil. Nakuha ba, kapatid? So therefore, using Faraday's of electromagnetic induction, so the induced voltage of the coil equal to N, number of turns, 2,000. So the change in the given flux, absolute value natin, so that is 100 minus 0. So gawin na lang natin 100,000. Change in time, from 0 to 0.01. So the total time elapsed, it should be what? 0.01. Yun nga lang, yung ating flux, naka-Maxwell, convert mo sa Weber. So I have a multiplier of what? 10 raised to negative 8. Just convert Maxwell into Weber so that your E is measured in volts. Okay? So kuha na. 2,000 times 100,000 divided by 0.01 times na lang 10 raised to negative 8. So we have now the induced voltage in the coil, which is 200 volts. So yun yung nahanap natin. Anong letter yan? 200 volts na yung cut style. Now! Ganun yung cut style, kapatid. Lalo sa probinsya, no? Pagka yung pusa gustong-gusto na. Mintik pa yung pusa, no? O kailan mahuhuli mo na yung tulog sa gabi, doon pa sila maingay sa bubong. Kalampagan sa bubong. O nag-aaway yung dalawang lalaking pusa. Kung sino matibay, siya matira matibay. Kasi pagka gusto ng makipag-mate ng babaeng pusa, malakas ang hiyaw na. Sa gabi, marinig mo, no! Kano ng hiyaw daw. So, marinig ng mga lalaki pusa. So, siyempre, alam mo naman mga lalaki, pagka nagbigay na ng go signal yung babae, alam mo na yan. Ready yan. Minsan dalawa o tatlong pusa ang darating. Hindi naman pwede tatlo ang magsabay-sabay doon sa isa. Kailangan isa-isa na. So, kung sino mauna, matibay. Away muna sila doon. Kaya maingay sila sa taas ng bubong. So, kung sino manalo, so siyang bahalang umariba doon sa pusa. So, kaya humihiyaw yun, kaya maingay. Pansin mo minsan, observe mo yung pusa. Sadista yung pusa. Pagka makikipag-mate na yan, abay, kinakagat yung batok. Kinakagat yung batok ng babae pusa. Kahit nga babae, di ba? Tingnan mo yung mga babae. Sanang kiliti sa batok. Hawakan mo lang yung batok. Talagang nakikiliti yan eh. Nanginginig-nginig, di ba? Kagatin mo, kapatid. Kagatin mo sigurado, hihiyaw din niya. Kaya gano'n nangyari sa pusa. Hiyaw na hiyaw, maingay. Kaya lentik yung pusa niya pagkagabi. Huling-huli mo na yung tulog. Manggigising pa. Mga now! Kaya now siya ng now. Gusto daw niya. Okay? Sa iwan ko si number 24. 25. Objective. Ano sagot, kapatid? Whenever conductor cuts a magnetic flux, EMF is induced. So, kanina pa natin pinag-uusapan yan. That is based on Michael Faraday's law of electromagnetic induction. Number 26. For number 26, kapatid, ay nahanap ng ating problem. Two coils with inductance of 4 and 6 Henry are connected in parallel. If their mutual inductance is 3 Henry, calculate the inductance of the combination if mutual inductance cease and it opposes the self-inductance. Ano ibig sabihin? Kumbaga, kung babalikan natin doon sa ating machines, generator, meron tayong tinatawag na compound generator, di ba? Sa inyong machines. So, sa compound generator, pag sinabing compound, we have two field winding. Yung ating shunt field winding at saka series field winding. So, meron tayong tinatawag na cumulatively compound generator at saka differentially compound generator. Ano ibig sabihin or pinagkaiba ng cumulatively at saka sa differentially? So, since meron tayong dalawang coil doon, so ibig sabihin, meron tayong two magnetic line of force. So, pag sinabi natin cumulatively, ibig sabihin, para siyang additive. Lumalabas, yung magnetic line of force produces by the shunt field and the magnetic field produced by the series field assist each other. Tulungan sila. Kaya tinawag natin cumulatively. Ngayon, yung differentially, so ito from the term differentially, difference is subtraction. Diba? Differentially from the word different, subtraction. So, ibig sabihin, yung behavior ng magnetic line of force produces by the shunt field at saka series field opposes each other. So, anong ginagawa? Dahil opposing sila, so mas humihina yung ating magnetic line of force. Kaya kung babalikan mo sa ating machines, si differentially compound generator, ginagamit lang siya para doon sa mga light loads, no? Mga pang light loads na magdagaan. Pero yung cumulatively, ginagamit doon sa mga high loads or heavy loads, no? Pang crane, pang elevator, pang hoist, okay? So, mabibigat na load. Pero yung ating differentially, pang light loads lang. Kasi mahina yung kanyang field because of the subtractive or opposing. So, ganito rin yung ibig sabihin ng ating problem 27 pa lang nabasa ko, no? 26 pa lang. So, anyway, unahin ko na muna yung 27 kasi yun ang aking na-discuss. No? Nalagpasan ko si 26. Balikan ko na lang si 26. Ano? Nakita ko si 27 eh. Total, yun na rin ang diniscuss ko kung bakit meron tayong tinatawag na opposes at saka assist. Pag sinabing assist, no? Yung field, magnetic field produces by these two coil assist each other, additive. Kaya mas tumataas. Pagka opposing, so that is what? Subtractive or differentially compound. So for number 27, we have 2 coils. Since ito yung nabasa ko na, so para touch move, unahin ko na kapatid. So let us consider we have 2 coils connected in parallel. Kunin na lang natin dito yung kanilang total inductance. Kunin natin total inductance. So we have 2 coils connected in parallel. So let's say the self-inductance of the first is L1, self-inductance of the second is L2. So ano hinahanap, no? If the self-inductance or the inductance of every coil here, L1 is 4 Henry, L2, that is what? 6 Henry. Now, if we try to get M, so sino si M? That is mutual inductance, which is 3 Henry. So ano hinahanap? Calculate the combinations or the total inductance of our 2 inductor connected in parallel if the mutual inductance assist sa ibig sabihin, cumulatively yung ating flux provided by our 2 self-inductance or opposes. Ibig sabihin, differentially opposite. It opposes each other. So what would be the total inductance? So required LTA. Total inductance wherein mutual inductance assist. So cumulatively. So tulungan yung ating dalawang coil. And LTO. Opposes. If subtractive yung effect ng ating flux provided by your L1 and L2. So how to solve for LTA and LTO? So basically, para lang tayo nagparallel dyan ng mga resistances. Yun nga lang, if you have to consider the effect of mutual inductance, so ito hindi ko na i-derive, para lang din tong galing sa parallel operations of resistance. So to get total inductance in parallel, wherein assist, mutual inductance assist, so, or cumulatively connected in parallel, that is simply product of self-inductance L1 times L2, i-minus na lang natin M squared sa baba, you have L1 plus L2 pag-assist, so this should be minus 2M. Kaya kung papansinin mo, if mutual inductance between these 2 inductor is what? Negligible. So, pwede natin tanggalin ito para ka lang nagparallel ng resistance, product over sum. So, this is total inductance when mutual inductance assist. Now, pag LTO, kapatid, mutual inductance opposes L1, L2 minus M squared pa rin. I-divide natin L1 plus L2 plus 2M naman. Sir, paano po kunin yung mutual inductance kung hindi given sa atin? So solving for mutual inductance, it is only equal to K square root of what? L1 times L2. Ano yung ating K? Ang tawag natin kay K is the coefficient of coupling. Wherein coefficient of coupling, K, it is usually less than or equal to 1. So that is less than or equal to 1. Kaya kung papansinin mo, kapag na-try nyo gumawa ng transformer, yung pang residential use na transformer, dati kasi pagka bumili ka ng appliances, kung yung father mo is abroad, so sigurado pag uwi niyan, so isa sa pasalubong usually mga electrical appliances galing sa ibang bansa. So nandun yung TV, nandun yung component. So dati pagka galing sa ibang bansa, yung iyong television, alam mo na imported yun kasi ang voltage niya 110. So para magamit mo rito sa atin, gagamit tayo ng mga transformer na step up natin yung voltage para gumana. So kung na-try nyo gumawa ng mga ganung transformer, so kapag winawind natin yung magnetic wire, kailangan talaga, no? Dikit-dikit. Maganda yung pagkakapatong or pagkaka-wind. Kung papansinin mo sa equivalent circuit, magka-separate yung primary at saka secondary. Pero reality, pagka ginawa mo yun, after mo matapos yung primary winding, so ipapatong mo lang doon yung ating secondary winding. So magkasama lang yun, magka-couple sila. So kung gaano kaganda yung pagkaka-coupling niyan, yun na yung tinatawag natin coefficient of coupling. So it's something related with respect to the flux provided by the given coil. If the flux provided in the primary will be totally linked sa secondary, no, wala tayong losses, walang leaking, so coefficient of coupling is 1. Pero alam naman natin, no, at any given time, may mga losses talaga. Meron tayong kinoconsider na air gap. Kasi kahit dikit-dikit yan, kahit pa paano may awang ng konti, may singit ng konti, so may air gap doon. So air, again, represent opposition to the magnetic line of force. So kahit pa paano, pinapahina niya ngayon yung flux provided from the primary, no, para mag-link sa secondary. So nababawasan kahit pa paano. Kaya nagkakaroon tayo ng losses. So that particular value represent by this coefficient of coupling. So kung walang binigay na coefficient of coupling, gagamitin natin yung highest value, which is 1. So that is the value for our mutual inductance. Okay? So dito, binigay na sa atin, so no more problem. Makukuha na natin ngayon, what would be the total inductance of these two self-inductance or two coil connected in parallel if their mutual inductance assist or their mutual inductance opposes. Okay? So, pwede na natin diretsuhin. Formula-based lang yan. Kailangan lang ma-recall yung formula. So, LTA, total inductance wherein mutual inductance assist, L1 and L2, that is the self-inductance, 4 times 6 minus 3 squared, i-divide natin 4 plus 6 minus 2 times 3. So, meron tayong 24 minus 9 is 15. Divide 10 minus 6, 4. So, 15 over 4, I think this is 3.75 Henry. So, that is the total inductance, wherein mutual inductance 6. So, finding LTO, parehas lang naman yung numerator natin, hindi magbabago yung numerator. So, this should be also 15. Sa baba, pag-oppose, instead of subtraction, addition. So, you have 10 plus 6. So, this should be 16. So, 15 over 16 in fraction, that is 0.9375 Henry. So, yun ang hinahanap ng ating problem number 27. Anong letter yan? Ayun. Now, cuts tayo. Nakuha ba, kapatid? Any question regarding problem number 27? Nabasa ko agad si 27. Kasi na-excite ako kay 27. Anniversary kasi namin ng misis ko yan. 27. Okay. So, balikan ko lang yung 26. No? So, medyo yung aking mata is, kasi kanina umaga, ang klase ko is sa NU, National University. Straight in na 4 hours. Kaya medyo yung aking mata parang nagluluha-luha na because of the radiation ng aking laptop. Kay laptop mismo ako nagsusulat kapatid. Tapos yun din ako natin. Kaya medyo yung aking mata nagluluha-luha na. Masyado na matagal sa harapan ng screen. Kaya nga, panalangin ko is magtuloy-tuloy na yung face-to-face. Para kahit paano, malimited na yung time ko sa harapan ng laptop. So, mas maganda kasi pag face-to-face. Ano? Pero of course, during this time, napakalaking advantage no face-to-face. Anong online? Unang-una, safety. Sa bahay ka lang. Hindi ka masyadong exposed sa maraming tao. So, medyo safe ka sa pagkahawa. Pangalawa, kapatid. So tulad ko, may baby pa kami. So during my break, kahit pa paano, agad, hindi ko na kailangan mag-travel. Kasama ko agad yung pamilya ko. So during the break, so kahit pa paano, nalalaro ko yung baby namin. No? At saka, less hassle. Hindi mo kailangan mag-travel. Sa bahay ka lang. Hindi mo kailangan magsuot ng mga formal attire. Minsan nga pagka nasa seminar, naka-coat ka, tapos sa pambaba mo, short, di ba? So, yun yung mga perks ng online. Kaya lang, syempre, pag face-to-face, marami rin namang advantage yung face-to-face. Marami ka nakakasalamuha, actual. So, in that case, medyo mas madali yung interaction, tsaka less sa radiation. So, at certain situation, may advantage at disadvantage lahat ng situation. So, palagi, tingin na lang tayo dun sa advantage, di ba? Kumbaga, sabi nga, or whatever scenario, try to find yung positive side. Huwag mong hanapin yung negative side. Kung tayo sa positive side para hindi natin isipin na mahirap or parang ma-stress. So, always look at the positive side. Ganun lang kapatid. Yan lang yung mata ko talaga nagluluha na. Anyway, let us try number 26. Kasi nakaligtaan ko si 26 eh. Agad nabasa ko. Okay, number 26. Field winding of a DC generator is wound with 900 turns and has a resistance of 50 ohms. If the winding is excited from DC source of 240, so ibig sabihin, for this given generator, since gumamit tayo ng external source to energize its given field winding, so tawag natin sa kanya is separately excited generator. So babalikan lang natin yung simple So, babalikan natin yung simple equivalent circuit ng ating separately excited generator. So, gumamit lang tayong external source to energize its given field winding. So, magka-separate sa equivalent circuit yung ating rotor at saka stator. So, pag DC, ang rotor, which is the rotating part, represent the armature. No? Although, babalikan din naman natin yan pagdating natin sa DC machines. No? Dito muna tayo mag-focus. So usually, no, sa mga planta, ginagamitan natin talaga or ating mga generator down is separately excited. At yung ating excitation voltage, it is always low voltage DC. So sabihin natin, this is the excitation voltage. So this would be the resistance of the field winding at ito yung ating excitation current. Usually, sabihin natin is IF or field current. So para consistent na lang tayo, lagyan ko na lang ito ng F, that is field voltage. Then we have the rotor. So you have the resistance of the armature conductor, that is RA, and the generated voltage at the armature. Which is our EG. Then we have the source. So, ayan yung ating equivalent circuit for separately excited. Ano? So, ito yung ating electrical load. The voltage required is the terminal voltage. So, here, ang consideration natin ay doon sa ating field winding. Dito lang muna tayo. Ano? So, separately excited, gumamit tayo ng external source to energize the field winding in order to provide the necessary flux to be cut off by the rotating armature coil in order to generate voltage according to Michael Faraday's. So, based sa problem, the number of turns of our field winding is 900, wherein its equivalent resistance RF, it is equal to 50 ohms, and the excitation voltage, it is equivalent to 240 volts. So once it is energized, so therefore we have the corresponding current. So the flux provided by our field winding or by the coil, it is equivalent to 4 milliweber. So ano hinahanap? Determine the self-inductance of the coil required. So coil yan, may inductance yan. What would be its self-inductance? So kanina, dinerive na natin how to solve for the self-inductance. Ano ang formula natin, kapatid? So solving for the self-inductance, you have only what? Lee, no? You have the self-inductance times the current that energizes the coil. It should be equal to the number of turns and the corresponding flux. So wala nang problema, meron tayong number of turns and you have the flux provided by our coil if the excitation voltage is what? 240. So kakailanganin na lang natin si current. Sinong current ito? That would be the current that would energize the coil, which is your IF. By Ohm's law, it is the field voltage over kanino? Field winding resistance. So substitute natin dyan, kuha na natin, therefore, inductance of our coil, number of turns, 900. Flux provide 4 milli, 0.004. I-divide natin kay current. Ano voltage? 240. Ano resistance? 50. So we have now the self-inductance. Okay na pa ba? So that would be our self-inductance for problem 26. So 900 times 0.004, i-divide po current by Ohm's law, voltage over resistance. 50 equal 3/4, or that is 0.75. Ang unit, it should be Henry. So that should be our answer. Walang H. Nako ba? So that would be our problem 26.75. So answer is Arriba. Also. Nagets? Any question regarding problem 26? Nauna lang konti yung ating 27. Iwanan ko siya, kapatid. Yo! Number 28. What is the coefficient of coupling of two coils whose mutual inductance is 1 and self-inductances are what? 1.2 and 2 Henry. So we have two coils which are coupled to each other. So the first coil has self-inductance L1, which is 1.2 Henry, while the second coil has a self-inductance of what? 2 Henry. So the mutual inductance of these two coils, it is only 1 Henry. Hinahanap, what is the coefficient of coupling? So that would be our K. So naibigay na natin kanina. So solving for K using mutual inductance, that is mutual inductance over the square root of what? L1 and L2. But actually, general formula niyan, it is equal to the ratio of flux produced sa primary winding that links to the secondary winding, or the flux provided in the primary coil that links to the secondary coil. I-divide natin the flux provided sa primary coil or primary winding. So that is the coefficient of coupling. Tawag natin dito is linking flux. That is the flux generated or produced by our primary winding that travel and link to the secondary winding. So that is the general formula for coefficient of coupling in terms of the flux provided by our coil L1 and L2. So here, walang binanggit sa ating flux. Instead, binigay yung mutual inductance. So using the formula of mutual inductance, makukuha natin yung ating coefficient of coupling. So direct substitution, solving for this coefficient of coupling, mga kapatid. Ano lumabas na value? 1, divide mo na lang, 1.2 times kanino? So, yun na yung ating final answer. Yes ba? Ano luwas kapatid? 1 divided by square root of 1.2 times 2 equal. So we have 0.645. That should be our answer. Anong letter ito kapatid? Valid chart. Okay? Any question regarding problem number 28? 29. Kapatid, kung kayo ang sasagot kay number 29, ano ang inyong answer? Since objective lang. Ano sagot ninyo kapatid kay number 29? Sige nga. Kindly comment ano sagot ninyo? No voltage will induce in a coil when current I is what? Switch on, reduce, switch off,
Switch off, sir.
constant. Ano sagot kapatid? Anong value? Ano sagot
Switch
mo?
off.
Switch off. Okay, possible. Yung iba. Mr. Nasyon, ano sa tingin mo sa'yo? Ang sagot mo? Kay Sir Majid, switch off. Okay. Sa'yo kapatid, ano sagot mo? No voltage is induced if current is what? Sa tingin mo lang, sige lang. What is your opinion? Ang sagot mo, sa tingin mo sa'yo, Mr. Nasyon? So, iba, C. Sila sa off, sir. Okay? So, yung iba, off din. Huh? So, at sagot, balikan natin yung binigay ni Michael Faraday. Ano? Whenever there's a changes or cutting of flux within a coil, voltage is induced. Tama ba? At yung coil, tulad ng binanggit natin kanina, this coil, asan siya? Ito. This coil is also what? Inductance. Tama ba? This is inductance. So, ibig sabihin, the voltage induced in this inductance, it is also the voltage induced in the coil. Ano voltage drop in the coil or in the inductance? Anong formula? L di over dt. Di over dt is the change in current. So, ibig sabihin, every time there's changes in the current passing through the coil, voltage is induced. So, ibig sabihin, pag switch on, so possible, dati siyang naka-off, anong current sa kanya? 0. Tapos bigla natin in-on. Nagkaroon ng current. Nagkaroon ng change in current, meron tayong voltage is induced. Now, reduce. So, pagka sinabing reduce, automatic, nagkaroon ng changes sa current. Binawasan natin. Ngayon, pagka switch off, di ba? Kapares ng problem 24, switch off, in-open natin. Dating, may 2 ampere nung switch off, anong current? 0. We have the voltage induced, which is 200. So, ibig sabihin, the voltage induced in the coil is always 0 kapag ano siya. Di ba? Di over dt exchange. So, kailan ito magsi-0? This is 0 kapag ang current is what? Constant. Okay? So, that should be the answer. No voltage will induce in the coil if the current I is what? Constant. Kasi walang changes in the given current. So, kung walang changes in the current, alam natin, flux and current are proportional. If current is constant, flux is constant, there is no also changes of flux. Kaya no voltage will induce. Okay? So 29, the answer should be dog style. Okay? Gets natin, kapatid. Any question regarding number 29? 30. Ito formula lang. Alam natin, capacitance has the capable or capacitance inductance. Ano formula ng energy stored in the inductance? So, ang symbol natin, ito sa L, this is always equal kanino? 1/2 L I squared. No? Doon sa ating P6. So, na-encounter natin yan. P6 2, energy stored in the inductance. Alam natin, yung ating inductor or inductance has the capable to store energy in the form of what? Electromagnetic. Capacitance has also the capable to store energy in the form of what? Statics. Tama ba, kapatid? Sir, pwede po pa-scroll up ulit sa choices sa number 29. Pa-screenshot po. Okay. 29. Ayan. Okay? Sige. So number 30, this is just a formula. Energy stored in the inductor is given by, alam na natin dapat yan, this is only based on kinetic energy. Ano ang kinetic energy? 1/2 mv squared. Alam natin, yung ating circuit parameters for inductance and capacitance, parehas siya. No, they have the capable to store energy. The stored energy in the inductance, that is in the form of what? Electromagnetics. Yung energy is stored in the capacitance, that is in the form of what? Electrostatics. So for inductance, 1/2 Li squared. For capacitance, 1/2 CVC squared. Kasi ang ating inductance, ano ba ang purpose ng inductance? The inductance opposes the change in current and capacitance opposes the change in voltage. Okay? So number 30, anong sagot? Formula lang. Again, my favorite, dog style. Dog style. Naku, alam mo na. Number 31. Kasi ang mga dog style, no, kumbaga ang pusa sa lista, kaya lang medyo, ang tawag dito sa pusa, no? Medyo, anong tawag natin dito? Kalimutan ko yung mismong term sa pusa eh. Kasi sa gabi, medyo disente. Kasi sa gabi lang. Tapos, tago pa sa taas ng bubong. Hindi mo masyado makita kung hindi mo talaga titignan. Eh yung mga aso, kapatid, minsan magdadrive ka, katanghalian tapat, nasa gitna ng daan. Diba? Yung mga askal, yung mga asong askal lang, yung mga lalo sa mga probinsya, di ba? Alam na alam ng mga asong lalaki na kapag yung aso sa kabilang bahay medyo naglalandi or gusto makipag-mate, di ba? Makikita mo talagang araw-araw dinadayo yun. Makita mo kahit sa gitna ng daan, katanghalian tapat nagyayarihan. So bakit kayong aso mga naglalaki? So 31, what is the correct induced EMF? So hinahanap lang natin the equation. Binigay na natin kanina. We have two general formula for the induced EMF. Meron tayong statically induced, that is N dP over dt, which is also equal the magnitude of dynamically induced voltage beta LB multiplied kanina sin theta. So alin dyan yung available sa choices? So theta represent the angle between the conductor and the magnetic line of force. Kasi kung try nating i-imagine, no? So alam natin yung rotor o yung ating armature ng DC generator, di ba umiikot yon? Continuously rotate yan within the pole. No? Yung pole yung ating magnet. So ibig sabihin, pag umikot yan, so every time na umikot yan, iba-iba yung angle between the magnetic line of force produces by the magnets or by the pole at saka yung conductor. So itong theta na to, that is the angle between the conductor at saka yung magnetic line of force. Pag hindi binanggit, considered as what? 90. Maximum ang ibig sabihin. Okay? So ngayon, ano itong beta? Beta is the flux density, the available flux provided per area ng ating pole. Yung L is the length of the conductor. At yung B is speed or the velocity. Kaya tinawag siyang this is dynamically and this is statically. So therefore, alin sa choices yung available. Wala tayong statically, sino meron? Dynamically, which is what? Beta, L, B. So anong letter? So at this case, the final answer, it should be what? Cut style again. Dilim na pala dito sa aking room. Okay, kuha ba? Any question regarding problem 31? 32. Flux of 14,000 lines. So, tulad ng binanggit ko, no? Magnetic line of force can be also measured in terms of lines. 14,000. Kaya kapatid, kung na-try ninyong mag-perform ng experiment at i-measure yung magnetism or the magnetic line of force provided by the magnet, di ba gumagamit tayo doon no magnetic sand? Nalagay mo, tapos ano mangyari sa kanya? Mag-scattered siya. Di ba? So kapag binisualize mo yon, You have the given magnet. Tingnan natin, yung magnet. Sabihin natin north and south. Di ba? Pag kinuha mo yung, pag dinraw mo yung kanyang equivalent magnetism, so anong dinodraw natin? Di ba? That is in terms of lines. Yan. So ito yun. These given lines, ito yung kanyang magnetic line of force provided. Kaya habang palapit tayo ng palapit, mas mataas yung force of attraction. Habang palayo ng palayo, pahina ng pahina. So kapag binisualize natin, kung ilang lines ito, yun yung kanyang equivalent magnetic line force. So ganun siya kalakas. So habang dumadami yan, so palaki ng palaki. So kaya pwede natin sukatin yung ating magnetic flux also in terms of lines, which is also equivalent to a unit of what? Maxwell. In terms of magnitude, lines is equal to Maxwell. So based on problem, if the flux density is 7,000 Gauss. So sino si Gauss? Gauss is the unit of flux density. Gauss, that is in CGS. So kapag kinuha natin ang equivalent unit ng Gauss, Gauss is the ratio of the available flux in Maxwell per square centimeter. So this given unit, it is measured in terms of what? CGS. So dalawa yan, ano? Pwede rin natin i-measure si flux density. Ano SI unit ng flux density, kapatid? Sige, naalala? Ano metric system or units for flux density? Ano SI unit ng flux density? Sa tingin niyo, naalala ko ba? Ano SI unit ng flux density? Ano siya, kapatid? Sige, naalala ba? Yung Gauss, that is in CGS system. How about in metric system? Ano unit ng flux density in metric system? Yes. Ano siya? Yes, very good. Tesla. So, ibig sabihin ng Tesla, metric system, flux over area. So, ano metric system ng flux? Weber. Area, square meter. So, Tesla is Weber per square meter. So, therefore, recall lang ulit, for every 1 Tesla, how many Gauss? Ano yung equivalent value niya? 1 Tesla is how many Gauss? Naalala, kapatid? 1 Tesla is how many Gauss? Ano conversion? Yan yung medyo kailangan, no? Medyo ngayon, dapat pa lang medyo dapat familiar tayo sa different units, lalo na sa mga electric parameters. Tulad yan, 1 Tesla is how many Gauss? Yes, very good. Kakaling talaga. Naksama na. 10 raised to 4. Yun. So, simple lang. Conversion lang, no? Alam mo naman yung centimeter to meter at Weber to Maxwell. So, okay. So, since here, hinahanap is the area in square centimeter. So, gamit na tayo CGS. So, alam na natin that flux is the available or flux density is a flux per unit area. So, therefore, the area now, it should be equal to 14,000 lines. It is equivalent to 14,000 Maxwell. I-divide natin sa 7,000. Ang Gauss, it is also Maxwell per square centimeter. So, cancel lang naman yung ating Maxwell. So, the area, it is now 8 square centimeter. So, obviously, it is only 2 square centimeter. That should be our answer. Ano letter? Ayun, cut style. Ako ha? Any question regarding problem number 32? 33, kapatid. A solenoid has magnetic reluctance. Sir, ano po yung solenoid, di ba? So, si solenoid, isa yan sa mga equipment na ginagamit natin for motor control. So, si solenoid, pang contact, kumbaga contact or first na link. So, pag inopen natin si solenoid, ang main component nun, yung kanyang coil. So, doon tayo mag-focus sa kanyang coil. Kunin natin yung equivalent circuit ng kanyang coil. A solenoid has a magnetic reluctance of 2.2 times 10 raised to negative 3. It has 300 turns and a core area of 5 square centimeter. What is the flux density when the current flowing is 1 ampere? So let us consider, kunin na lang natin yung equivalent circuit ng kanyang coil. So let us consider this would be the equivalent coil ng ating solenoid. Binanggit ng problem, the number of turns, you have 300, and the reluctance of the core, kung saan natin winain yung ating conductor, its reluctance is 2.2 times 10 raised to negative 3, wherein the area of the core, that is 5 square centimeter. Let's say the given solenoid is energized by our DC current, wherein the current flowing in the coil, it is equivalent to what? I is 1 ampere. So, ano hinahanap? What would be the flux density? So, kung papansinin natin, Gauss. So, dapat CGS. Alam na natin ang formula ng flux density, the available flux per given area. Okay na tayo sa area. Kuha na natin. Ang problema, wala pa tayo flux. Saan natin kukunin si flux? So, solving for the value of our flux, balikan natin yung Ohm's law for magnetic circuit. Okay? So kapag kinuha natin si MMF, that is actually the product of what? The flux at saka sino? Reluctance. Wherein MMF can be also computed using what formula? 0.4 pi times N times I. Okay? So that is also the formula for your MMF. Kumbaga, si induced voltage, so in terms of Ohm's law, current times resistance. Meron tayong induced voltage based on Michael Faraday, that is NdP over dt. So ganun din yung ating MMF. So it has also its given formula as 0.4 pi times N times I. Current. So kapag ginamit natin 0.4 pi, the unit of your MMF, it's measured in terms of what? Gilberts. Okay? So, unit of your MMF, Gilberts. So, pag naka-Gilberts yan, it is measured in what unit? CGS. Naka-CGS system yan. Now, alam natin, kung may CGS, meron tayong metric system. So, in SI, your MMF, pag naka-metric system tayo, sabi ko to, MMF, Ohm's law is still flux times R. Now, kapag SI or metric system, it is just simply equal to number of turns multiplied kanina, current. Kaya ang unit ng ating MMF in SI, it is measured in terms of what? Ampere turns. So that would be the two unit used to measure the MMF. Pwede natin gamitin in CGS measured in Gilberts, or pwede mo i-measure si MMF in terms of ampere turns. So that is in what? SI. So since in the given choices, the flux density should be in Gauss, ibig sabihin, ang gagamitin natin is ano? CGS. So pag CGS, automatic, yung flux natin dito measured in what unit? That is in Maxwell. Nakuha ba? So therefore, using Ohm's law, makukuha natin ngayon that the corresponding flux it should be equal, ano value? MMF, magnetomotive force, i-divide natin kanino? Reluctance. At si MMF in CGS value, it is equal to 0.4 pi times turns times current. I-divide natin kanino? Reluctance. So that would be the corresponding flux. So makukuha natin ngayon si flux. Solving for the value of our 4 times pi. Ilang turns lahat meron? 1 ampere. Ano reluctance or the opposition offered by the core of the solenoid in the given flow of magnetism? So that is 2.2. Sir, ano po unit ng reluctance? Kapag naka-CGS, in CGS, the unit of reluctance is unitless. Okay? Dimensionless reluctance in what? CGS. But in metric system, the unit of your reluctance that is based on Ohm's law. Reluctance in SI is ampere turn per Weber. Okay? Ampere turn per Weber yung ating reluctance kapag ka SI or metric system. But in CGS, reluctance is dimensionless. Walang unit si reluctance kapag naka tayo CG. Ginagamitan lang ng unit si reluctance kapag nasa metric system. Yung iba, ang unit ng reluctance na ginagamit is the reciprocal of Henry. But most of the time, using Ohm's law, ampere turn per Weber is the unit of reluctance in SI. Okay? So therefore, since naka-CGS tayo, automatic, yung ating sagot dyan is naka-Maxwell. Okay? Kung again, so you have 0.4 shift pi times 300 na lang. I-divide natin sa reluctance of 2.2 exponent of -3. So this would be the total flux provide in the coil in terms of what? Maxwell. So ilan ito? 171,359.6. So take note, pag Maxwell, malalaking value. Kung naka-Weber yan, palagi milli lang ang value. Pero pag Maxwell, nasa thousands, 100,000s. Pero pag Weber, nasa milli values. So therefore, flux density, that is the available flux, i-divide na lang natin kanina, area. Ano area? Ayun, 5 square centimeter. So Maxwell per square centimeter, that is Gauss. So i-divide na lang natin 5 equal. So the flux density, that is only 34,271.92. Anong unit yan? This is now measured in Gauss. That should be the answer. Pero ba? Ayun. Pwede natin consider Katz type again. O ha? So, any question regarding how to solve for the flux density? Yun nga lang, ginamitan natin ng Ohm's law under magnetic circuits just to solve for the flux produced in the given coil of our solenoid if it is energized by 1 ampere of current. Okay? So, iwan ko si number 34. So, ba't naman? Saan yung... Okay. Search ko lang. So, 34, when the current in the wire is 5 ampere, the flux 3 meter from the wire is 13 milliweber. If the current decreases to 4 ampere, what will be the corresponding flux? So, siguro na-try din natin, no? So, dati, laboratory sa physics. Kuha ka ng alambre. Diba? Alambre, tapos iwind mo sa pako. Tapos yung magkabilang dulo ng alambre, lagyan mo battery. Ano nangyari, kapatid? Di ba, para siya naging magnet. So, naging magnet yan. So, makikita mo, so it will attract certain metal. So, kaya alam natin that the flux or the magnetism, it is always proportional kanina current. So, pag tinanggal natin yung battery, so balik lang tayo sa original wire. So, So therefore, alam na natin kanina that flux is always proportional kanino current. Lino. And also, based on the Ohm's law, flux is proportional to the current kasi ang reluctance ng circuit constant. Number of turns of the circuit is constant. 0.4 pi is also constant. Kaya flux is always directly proportional to the current. So based sa problem, if the current passing through in the given coil, it is 5 ampere, we have found out that the flux provided by the coil measured as what? 30 milliweber. Now, let us try to consider decreasing the current from 5 ampere. Let us decrease to 4 ampere. So, what would be the possible value of the flux provided by the same coil? Right? So, nakita na natin that flux is directly proportional to the current. Therefore, using ratio and proportion na lang ulit. Diba? Using ratio and proportion, getting the ratio of final flux produced by a given coil with respect to its initial value, it should be equal to the ratio of final current over initial current supplied in the given coil. So, kuha na natin that the available flux now, it should be equal. Initially is 30, current 4 over 5. So, therefore, the final answer should be what? 24 milliweber. As what we expect, since these two are directly proportional, decreasing the current will decrease also the magnetic line of force or flux provided by our coil. So from 30, it would reduce to 24 milliweber. Yun ay hinahanap ng ating problem, 34. Anong letter yan? Ayun, arriba. Ako ha, kapatid. Question regarding 34. 35. An 80 centimeter long conductor carry a current of 3.6 ampere situated on a right angle to a field of flux density which is 0.95 Tesla. So what is the force of the conductor? So nasan yung force of given conductor? So for number 35, para ma-visualize lang natin, lahat to scale, ano? Okay, so let us consider, no? Let us create. So, kuha tayo ng simple single loop conductor. Should be our conductor. So, we have the pole or the magnet ng ating generator. Let us consider the magnetic line of force is from north to south. So therefore, we have a conductor. So pag kinuha natin yung angle between the base of the conductor at saka yung ating magnetic line of force, so they are situated at what? 90 degree. Kumaga, ito yung magnetic line of force, ito yung pinaka-base ng ating conductor. So ito si magnetic line of force, ito yung base of conductor. So they are what? Perpendicularly. No? Perpendicular. Hindi lang makita. No? Perpendicular yan. So single loop lang ang kinuha natin. So therefore, alam natin, whenever there is a changes or cutting of flux within a coil, voltage is induced. So therefore, you have the current, the magnetic line of force, and you have the corresponding force. So paano natin nalaman yung direction ng ating force at saka ng current at saka ng magnetic line of force? Kung babalikan mo yung ating left-hand rule, no? Ating left-hand rule. So usually, sa magnetic circuits, to identify direction, hindi makita. Hindi nakukuha ng aking camera yung aking kamay. So, left hand rule. Yung inyong left. So, yung thumb. So, tingnan mo yung iyong kaliwang kamay. So, i-open mo lang yung iyong thumb, yung index, at saka middle finger. So, yung thumb, diba, harap mo sa'yo, pataas yun. Ito, diretso, then yung index finger, padiretso sa'yo. So, ano na-represent ng thumb, ng index at middle finger? Yung middle finger, padiretso sa'yo, yung thumb, harapan mo, ay yung index, harapan, then the thumb, pataas. So, it always represent the direction of what? So, ang analogy dyan, FDI. So, the thumb is the F, the index is the beta, and the index or the middle finger is the current. So, ibig sabihin yung thumb, yun ang direction of force. Yung ating index finger, that is the direction of the magnetic line of force. Then, yung ating middle finger is the current. Kaya kung papansinin mo, itong ating green represent the direction of your magnetic line of force. That represent your thumb or your finger. So, ito yung mata that represent the thumb. So, ito ngayon yung ating current. Papasok sa atin, so that is the index finger. So, that is based on the left hand rule. So, therefore, if you have the force that is acting upward and downward, so ano mangyayari? Iikot ngayon yan. Kaya meron tayong continuous rotations of the conductor within this magnetic line of force. So, hinahanap, if this given conductor is exposed to this magnetic line of force wherein the flux density according to problem is 20,000 volts in CGS, ano? And the current provided in the given conductor I equal to 1 photo, a conductor of 1 meter long cuts the flux perpendicular at a speed of 40 meter per second. So, hindi binigay yung current. Wala tayong current. But instead, given yung length ng ating conductor, which is 1 meter, at yung speed of rotation is 40 meter per second. So, ano hinahanap, kapatid? Uy, bakit si 36 na naman ang nakikita kong data? 35 pa lang, 36 ang kinuha kong data, kapatid. Yan pala, wala yung current. So, given length of the conductor, 80 centimeter, so it should be 0.8 meter. Current in the given conductor ay yung given, which is 3.6 ampere. And the flux density, that is 0.95 Tesla. So, what force on the given conductor? So, required how to solve for the corresponding force. So, paano natin kukunin yung force acting in the given conductor that causes the rotation of our conductor within the magnetic line of force? So, paano natin kukunin yung force na yan? So, kung nakaligtaan mo yung formula, pwede mo balikan yung ating power. So, naalala, ano formula ng ating of your voltage multiplied kanino? Current. Tama, that is the power. Ano nga equivalent unit ng power? Di ba power, it is measured in terms of watts. Ano equivalent unit ng watts? Watts, it is joule per second. Tama? Ano equivalent unit ng joule, kapatid? Newton meter. Tama? So, divide ko na lang ito ng second. Ano ibig sabihin, kapatid? Di ba Newton is a unit of what? Force. Meter per second is a unit of what? Velocity. So, ibig sabihin, yung ating power can be also compute as the product of force times the velocity. Now, kung gaano kalaki itong force exerted on the conductor, multiply mo kung gaano siya kabilis umikot, that is also the power generated in the given conductor. Okay? So, ang problema, hindi binigay yung ating velocity at hindi binigay yung power nito. So, kung babalikan natin, power is E times I. Alam na natin that the given voltage, ano nga formula ng voltage, kapatid, dynamically? That is beta L B sin theta. Tama ba? So, ang gagawin ko ngayon, kapatid, let us substitute this equation here para makuha natin ang formula ng power. Lumalabas, E is beta LB sin theta multiplied kanino? Current. Ngayon, ang gagawin ko, ipasok ko si current, i-times ko si L, sin theta, tapos ilabas ko si B. Di ba alam natin, itong B na to is the velocity. Now, try to compare. This is the equation of power, which is, alam natin, it is also force times the velocity. Ano pwede natin sabihin nun? Lumalabas that beta IL sin theta, it should be equivalent to what? Force. So, kapatid, so lumalabas that the magnitude of the force on the conductor that carry a current, it is equal to beta IL multiplied kanina sin theta, which is measured in what? Siyempre, ano unit ng force? It should be 8 Newton. So, para maging Newton yan, dapat ang flux density naka-ano? Tesla. Dapat ang length ng conductor naka-meter. So, lahat naman ng data is given. Anong binanggit, kapatid? That the given conductor situated at a right angle. So, at a right angle, therefore, theta is at what? 90 degrees. So, you have now the corresponding force. Ano lumabas, kapatid? Flux density given na, 0.95, naka-Tesla. Ano yung current in the given conductor? 8.6 ampere. Gaano kahaba yung ating conductor? 0.8. Ano angle between the magnetic line of force and the conductor? That is 90. So therefore, you have the final answer. Yun na siya. 0.95 times 3.6 times 0.8 na lang equal. Ilan yan, kapatid? You have 2.736. Anong unit? Newton. That should be the answer. That is the equivalent force exerted on the conductor that carry a current. 2.736. Anong letter ayun? Dog style. Ha? Ako, ito rin yung binanggit ko sa inyo kanina, no? Kapag kumuha ka ng alambre, nilagyan mo na winay mo sa pako, tapos nilagyan mo ng battery. So therefore, yung ating alambre naging magnet. So para maging magnet yan, nag-exert siya ng attractive force. So kung gaano kalakas, no? Yung attractive force ng ating wire, yun ang tinatawag nating force on that given conductor that carry current. Kaya kung papansinin nyo, no, kapag yung ating construction ay malapit sa primary distribution line, naglalagay tayo ng insulation. Kasi pagka sobrang taas ng voltage sa iyon, you have the corresponding amount of current. So kahit hindi mo siya hawakan, so pwede ka na ngayon, higupin because of this given force. Kaya naglalagay sila ng kulay orange na insulation just for the protection. Ha? Kasi not enough, no? Hindi na kailangan pang hawakan yan para ma-experience natin electrocution lalo sa mga high tension wire. So at a certain distance, kaya nga pinagbawal na yung mga transmission line na medyo malalapit sa mga bubong, lalo sa city. Kailangan malalaki yung or matataas yung ating transmission or support tower para medyo malayo yung distance ng ating high tension wire sa mga bubong para minimize yung force of attraction between the corresponding line at saka yung bubong para maiwasan yung aksidente. Okay. So, any question regarding problem number 35? 36. Flux density from a pole is 20,000 Gauss. Conductor of 1 meter long cuts the flux perpendicular at a speed of 40. What is the voltage developed? O kakagamit lang natin that the induced voltage E, it is always equal kanina theta LB sin theta. Take note, dapat ang flux density naka-Tesla, yung length of the conductor naka-meter, yung velocity dapat meter per second, so that the unit of our induced voltage should be measured in terms of what? Volts. Nakuha ba? So para maging volts yan, dapat yung ating flux density naka-Tesla, yung ating length of the conductor naka-meter, yung velocity meter per second. So yung length naka-meter, yung speed 40 meter per second, isa lang kailangan natin i-convert from Gauss to Tesla, which is, alam na natin, yung conversion kanina. So therefore, direct substitution na lang si 36. Flux density in Gauss is 20,000. Convert natin si Gauss into Tesla. So i-times natin that for every 1 Tesla equal to ilang Gauss yan? 10 raised to 4. Tama ba? No? Tinanong ko sa inyo kanina ito kapatid. Multiply length of the conductor 1 meter is speed at which the conductor rotates around the magnetic line of force. So naka-meter per second. So gawin ko na ng 40. Maliwanag kapatid, situated perpendicular. Pag perpendicular, ano angle nun? That is 90. So, cancel natin yung Gauss. Yung length ng conductor, naka-meter na. Yung speed, meter per second. Therefore, the unit for our induced voltage, it is now in terms of volts. So, meron tayong final answer. Ano ba, kapatid? So, 20,000 convert into Gauss, divide ko na lang 10 raised to 4. So, i-times ko na lang ito kay 40 equal. Ayun. The final answer should be only 80 volts. Ang letter ay yung cut style. Nakuha? So, that is only direct substitution dun sa ating beta LP, dynamically induced voltage in the given coil. Iwanan ko, kapatid. Number 37. A DC electromagnet is wound with 1,000 turns of wire having a resistance of 30 ohm. When excited by a voltage of 125 volts, a magnetic flux of 2 milliweber links the coil. What is the energy stored in the given magnetic field? So, kumuha tayo ng magnet, ano kapatid? Let's say, ito yung ating magnet. So, para mas lumakas yung kanyang magnetization, so nilagyan natin ng wire yan. Front view na lang, no? Sabihin natin, uy, so para mas lumakas yan, nilagyan natin ng wire. Then yung ating wire, kinonect natin into certain electric source. Sabihin na lang natin is what? DC. So lumalabas that the number of turns and 1,000 turns of wire. Wherein, wire yan, may resistance. Resistance of the coil, RF, sabihin na lang natin, ilan siya? 30 ohms. Then, the given voltage supplied, it is 125 volts. So, my voltage, you have now the current. And due to the current, the field winding will provide the necessary flux. Anong binanggit ng problem? The flux length is 2 milliweber. So, what would be the energy stored in the magnetic field? So, sino bang parameters ang may kakayahan na mag-store ng energy in the form of magnetic field? So, yung ating coil represent what? Inductance. So, kung babalikan natin, ano energy stored in the inductance? That is always equal to 1/2 L I squared. So, meron na tayo current. Saan natin kukunin si current? So, by Ohm's law, your current, it is only equal to what? Source voltage over the equivalent resistance of the coil. So, no problem. Problema na lang natin, inductance. How to solve for the inductance of our winding? Diba? Anong formula? No. So therefore, pag kinuha natin si L, anong formula? N flux over kanina I. So para isang compute tayo, kapatid, itong inductance ng ating coil, ipasok natin dyan. So which means, this given energy can be simplified as what? 1/2. Ano si L? NE over I. So magka-cancel yung isang I. Ano na lang ito? Noy. 1/2 noy na lang, no? Kasi magka-cancel na yung isang current dito sa baba. So wala na problema. Lahat ng data is given. So you may now compute the energy stored in this inductance. 1/2 number of turns of our winding. 1,000. Right? The flux provide 2 milliweber, so 0.02. Ano current? By Ohm's law, ano si voltage? 125. Ano resistance of the field winding or the coil? 30. Ano unit ng energy? It is always measured in terms of what? Joules. So ha, ilan lumabas kapatid? Kindly counter check. So 1,000 times 0.002 times 125, i-divide lang natin ng 2 times 30. So this would be in terms of joule. So ilan siya? 4.167 joules. That should be the answer. Anong letter yan, kapatid? Anong letter? So this should be dog style. Okay, nako ha? Any question regarding dog style? Ay, direct substitution. Good. Okay, so may tanong ba, kapatid? Any question for number 37? Kaya pa ito, 38, kapatid. An iron ring electromagnet. So, ulit, kumuha tayo ng magnet. Saan tayo nakakita ng ring magnet, di ba? Pagka may sira tayong speaker, tignan mo, doon sa likod ng speaker, meron tayo doon malaking magnet, circular magnet. Ano? Tapos, meron siyang naka-wind na magnetic wire, yung brown wire. So, that is our iron ring. Drawn na to scale. Yung almost similar with problem number 37. Ngayon, yung magnet lang natin circular, di ba? Yung mga magnet sa likod ng speaker. So para mas lumakas yung kanilang magnetism, pansin mo, meron tayong wire. 9. Nilagyan natin ng wire yan. So that's considered, ito siya, no? Okay. So they're not the scale. That would be our iron ring electromagnet. So para mas lumakas yung kanyang magnetism, so nilagyan natin ng magnetic wire. Then, sa kabilang dulo, nalagyan natin ito ng source. Connected natin sa DC source. So therefore, we have the current. So if current pass through the coil, so flux will provide. Anong binanggit ng problem? Ano yung ring? So ibig sabihin, itong ring natin, that is made up of iron. The material, itong ating ring na to, that is made up of iron, having a relative permeability. So, relative permeability. So, sino yung permeability na yan? Relative permeability, that is our use of R. So, relative permeability, from the term permeability, permeance. No? So, that is the measure of the ability that the given material attract magnetism. So, this iron material, alam natin, so si iron, pag nilagyan natin ng magnet, attracted siya sa magnet because of its permeability. Ano binanggit? Its permeability, this is constant per corresponding material. Relative permeability is a unitless value. So for this iron, its relative permeability is 1,250. With the coil, number of turns ng ating coil, 500 daw. Wherein the current supplied to our coil, it is only 0.8 ampere. The mean length of the iron part is 48 centimeter. So the length, no? So mean length, since naka-circular yan, so ito yung kanyang mean diameter. So pag kinuha natin si mean length, it represent the circumference nito. Okay? Eh since binigay na sa atin, the length of the iron, ilan siya? 48 centimeter. Gawin natin meter. 0.48 meter. Wherein the cross-sectional area ng ating ring, it is equivalent to 10 square centimeter. Now, ito na binanggit natin, kahit ano gawin natin, kahit since no, gandahan natin yung pagkakawind, hindi talaga natin maiwasan na meron talagang gap between winding. So, merong air doon, may leakage. So, therefore, the air gap also offered its opposition to the flow of magnetic flux. So, based sa problem, kapag sinamarize or tinotal natin yung kapal o yung thickness, no, yung total gap in terms of air, so the length of the air gap, let us consider L sub A na lang. Gaano kahaba yun? 0.5 centimeter. So ano hinahanap? What would be now the total reluctance? Sino nga yung reluctance? That is the opposition offered by the circuit in the magnetism. Anong formula ng reluctance? Sinong counterpart ng ating reluctance? Resistance. Ano formula ng resistance? Rho L over A. Therefore, ang reluctance instead of rho, yung nu, Greek letter nu, na parang small b, pero ang kanyang pronunciation nu, no daw, nu, multiplied kanino? L over area. Sino ito, kapatid? This nu represent relectivity. At ang ating relativity, it is always the reciprocal of mu. Sino yung mu? This mu is known to be permeability. Anong value ng permeability? Permeability is always mu sub O, mu sub R. Mu sub R is relative, which is constant. Kaya lang, constant yan, depende sa material. Ibig sabihin, iba ang relative permeability ng iron, ng copper, ng steel, sa soil, or pero itong mu sub O, absolute. So pag sinabi nating absolute, iisang value, constant yan. Absolute permeability. Anong value? So no need to memorize. Tandaan mo, si mu sub O na kay calculator, constant 33. May mga constant sa calculator. So si absolute permeability ay na kay number 33. So therefore, solving now for the reluctance, pag total, it should be the reluctance offered by the iron plus the reluctance offered by the air gap. Ano formula ng reluctance? So that is relativity length over A. So ano sa relativity? Reciprocal ng permeability. So ibig sabihin, for iron, this should be the mean length of the iron, mu sub O, mu sub R ng ating iron times cross-sectional area of the iron. So same formula. For air, length of air gap, mu sub O, mu sub R, cross-sectional area for the air gap. So that is the total reluctance. Now, binigay lang sa atin relative permeability is the for the iron. Walang air. So take note for air, this is always 1. That is only for air. O, ha? So therefore, para ito is in terms of ampere turn per Weber, ibig sabihin, ang unit na ginamit natin dito is SI. Naka-SI yan. So kung SI yan, dapat yung length i-convert natin into what? Meter. At yung area kailangan naka-square meter. Ang unit kasi ng ating absolute permeability is per meter. Kaya nga yung iba, ang unit ng inyong reluctance, tingnan mo kapatid. So, Henry per meter si mu sub O, yan ang kanyang standard unit. So, tataas itong meter na to. Meter times meter is square meter divided by square meter cancel. Ano matirang unit? 1 over Henry. Kaya sa metric system, 1 over Henry, it is equal to ampere turn per Weber. Kaya huwag ka magtaka, minsan may encounter mo that the unit of reluctance, it is measured in terms of what? 1 over Henry. Ibig sabihin, naka-metric system ka doon. Okay? Pinuha ang kanyang unit based on the unit of your absolute permeability, which is always measured in what? Henry per meter. Kaya kung babalikan ninyo yung inductance per phase ng inyong transmission line, anong formula ng inductance per phase sa inyong transmission line? Naalala ba kapatid? 2 pi or 2 times 10 raised to negative 7. Naalala kapatid? Inductance per phase. L per phase, naalala? 2 times 10 raised to negative 7. Lone of what? GMD over GMR. Naalala yung formula na yan? Inductance per phase ng transmission line. Anong unit niyan? Naka-Henry per meter. Tama ba? So, saan galing yung Henry per meter? If I'm not mistaken, check natin, ano? Okay. Ligtas. Uy, baligtad na yata. Oh. Ay, napaligtad ko. 33 over 2 shift 5. Yun, kapatid. Ha? Doon nanggaling yung 2 times 10 raised to negative 7. That is U sub O over 2 pi. Kaya nga ang unit niya is Henry per meter. Kasi ang unit ng ating U sub O, it is Henry per meter. Okay? So therefore, para ito maging ampere turn per Weber, kailangan yung length naka-meter, yung area naka-square meter. So convert lang natin si 0.5 centimeter at 0.5 centimeter into meter, yung ating 48 centimeter na convert na natin sa meter. So 0.5 centimeter, divide na lang natin ng 100. So it should be 0.005. So that is 5 milli, or this is also equivalent to 0.005 meter. This area, then, i-divide na lang natin ng 100 square para naka square meter na. So this is only equal to 0.001 square meter. So wala nang problema. We have the area, we have the length, you have the relative permeability for the iron, which is 1,250. For air, it is always 1. So direct substitution to our total reluctance. So itong formula na to, it is only based on the formula of our resistance. Kung babalikan mo, ano si resistance? Rho L over A. So ito, instead of resistivity, reluctivity lang. Okay? So ibig sabihin, counterpart ng resistivity, sino? Si reluctivity. Ano reciprocal ng reluctivity? Permeability. Ano reciprocal ng resistivity? Conductivity. Kaya ano reciprocal, ano counterpart ng permeance? Conductance. Kasi si permeance, permeability, counterpart is what? Conductivity. Kuha ba yung relation between electric and magnetic circuit? So therefore, no more problem. Pwede na natin diretsuhin. Total reluctance. Length of the iron converted into meter, 0.48. Over, ikaw na mag-input ng mu sub O, constant 33, mu sub R, 1,250. Area, 0.001. Iangat ko na lang ng konti. So, area, that is 0.001. No? Kinonvert na natin sa square meter. Plus, the reluctance offered by the air, the total length of the air gap, we have already computed as 0.005. Mu sub O, relative permeability of air, it is always 1. So, same area lang yan, 0.001. So, therefore, the given reluctance, it is measured in terms of 1 over Henry, which is also the same as ampere turn per Weber. Now, 80, that is the acronym for ampere turn. So, si ampere turn is your mmf, Weber is the flux. Kaya by Ohm's law, reluctance is voltage over the current. Ano yung voltage sa magnetic circuits? Si mmf. Ano unit niya? Ampere turn. Ano unit ng current or ng flux? Weber. Kaya equal din yan kay ampere turn per Weber. Okay, kuha. So therefore, this is 0.48 divided by 1,250 times shift constant 33. Lalabas din yung 10 times the area 0.001. Last na natin, reluctance offered by the air gap 0.005. That is the length of the air gap. Shift constant 33 na lang since relative permeability is 1. Times na lang natin kay 0.001. So we have now the final answer. Gawin ko na lang siya English value. Ano ang lumabas, kapatid? So this is equivalent to 4.284. 4.5 na lang. Times 10 raised to positive 6. So that should be our answer. Ali yung available dyan. So, pwede ba, kapatid, gawin ko to 428.4284. 4284. 0.5. So move ko pa yung decimal point, 1, 2, 3 to the right, minus 3. So this should be times 10 raised to 3 ampere turn per Weber. So this would be the available value sa choices. Anong letter yan, kapatid? Ay, yung kita. Baligtaran. Okay, kuha? So any question regarding how to solve for the reluctance? So para hindi mo kailangan i-memorize yung formula, tandaan mo, the reluctance is the counterpart of our resistance. Para ang kanyang formula, it would be only based on the formula of resistance. Ang pinagkaiba, instead of resistivity, reluctivity ang gagamitin namin. Okay? So, any question regarding number 38? 39. So, the answer here, hindi ko na isusolve. Number of turns lang. So, kayo na bahalang mag-solve. Number 39. So, the answer here, baliktaran. Number of turns. Okay? So, saan mo kukunin yung number of turns? So, makukuha mo yan kay Lino. Yan. Gamitin mo si Lino, makukuha mo yung number of turns. Sakto yan, 400 turns. Number 40, nakuha na natin ang formula. Mutual inductance. Ano formula ng mutual inductance? Coefficient of coupling is square root of L1 and L2. Ano coefficient of coupling? Maliwanag, no? Unity coupled. Pag unity is 1. K is 1. Okay? So direct substitution. M is square root lang. Ano self-inductance? 6 at saka 8. So you have now is square root of 6 times 8. We have the answer. Ano value? 6.92 Henry. That should be the answer. Rounded up to whole number, pwede nating gamitin. Ano siya? Ayo. Dog style. Yo, my favorite. Dog style. Okay. Okay. So, may tanong pa ba, kapatid? I think that would do it for our business circuits. Tignan mo, kapatid, no? Sa review, tignan mo, tinapos natin ng 6 hours. Yung DC circuits, gaano katagal yan nung undergrad? Isang buong SEM. Sa buong SEM, ilang oras kada meeting yung DC circuits? Nung sa amin nun, 4 hours per meeting. Tapos 3 times a week pa. Pero sa review, sa actual review, 9 hours ang DC circuits. So dito, medyo tipid ng konti yung oras kaya ginawa lang 6 hours kasi binigay yan, no? So ganoon talaga pagdating sa review. Kaya nga napaka-importante nitong ating mga online review, no? Kumbaga in-house review ang tawag namin dyan. So para pagdating sa actual review, hindi tayo magkakaroon ng culture shock. Sir, yung 80 equivalent sa voltage, sir? Yes! Yung 80, that is the unit of your ampere MMF, no? Yung unit ng MMF. So ibig sabihin yung ampere turn, that is the unit of MMF. So kapag in-equate natin sa electric circuits, siya yung equivalent ng ating voltage, no? Analogy but not represent voltage is equal to ampere turn. Kundi the counterpart of ampere turn sa electric circuit is si voltage. Kuha ba, kapatid? Pero not necessarily 1 volt is equal to 1 ampere turn. Hindi siya ganun. Kumbaga, counterpart lang. No, para hindi tayo maligaw kung anong formula ng magnetic circuit, babalikan yung formula lang sa electric circuits at kung sino yung kanyang counterpart. Para recall mo yung formula ng magnetic circuits, basta alam mo si electric circuits at kung sino yung kanilang counterpart sa magnetic circuits. Okay? So, ampere turn, unit of MMF, which is the counterpart of EMF, which is measured in terms of voltage. Okay? Go ahead. Tapos yung Weber sa current, yes. No? So counterpart ng Weber is the current. Yun. Ang counterpart ng ohm is si reluctance or counterpart na resistance is the reluctance. Kaya tandaan mo yung counterpart ng electric circuit sa magnetic circuits para alam mo kung anong formula ng magnetic circuits. Ibabase mo lahat sa formula ng electric circuits kasi sigurado ako 1,000% kakilala natin ang formula ng electric circuits. Minsan lang, kasi hindi masyado nabibigyan ng pansin si magnetic circuits, Kaya most of the time, medyo nakakaligtaan natin yung different formula kay magnetic circuit. Kaya kung alam natin ang counterpart niya sa electric circuit, sigurado, you may recall the formula. Ganun lang siya. Okay. So, may tanong po ba tayo, kapatid? Any more questions? So, tignan mo, tapos agad yung ating DC circuits. Tinikat natin ng isang buong set.